Hi everyone, I welcome you all to the live session on Cloud Security tutorial by Intellipaat. This session is conducted by a cloud expert who is having more than 15 plus years of industry experience.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Now let's see the agenda of the day. Firstly, we will begin with Introduction to Cloud Computing. In that, we will tell you what is cloud computing and what are the different roles in cloud computing. Post that, we will be talking about cloud building blocks and cloud architecture. Then later on, we will learn about security concepts and security principles. Then we'll move on to how to design and implement cloud storage, design and also how to apply data security technologies. Post that, we will be learning how to design and implement IMR, that is Information Rights Management. Then later on, we will be learning about planning and implementing data retention. Then lastly, we have covered how to design and implement Auditability and Traceability. So guys, this is the agenda of the video. Now let's begin the session.
Here we'll take a look at what are the concepts that are associated with cloud computing that we should know about. So let us begin. We'll begin by taking a look at what exactly is cloud computing. Let us begin by answering a very simple and key question in that regard. A question that comes in our mind very often when we're talking about cloud computing is what exactly is it? Well, think about it in terms of what cloud computing provides us. If there was no cloud computing, as in we were living in an era where cloud computing was not a thing, think about sometime before 2006 or 7 when AWS was released. Before cloud computing was available, deploying an application was a massive task. This was really difficult. Suppose you have an application idea and you just want to try it out, just a proof of concept. But even for a proof of concept, you need some infrastructure backing it up. So if you're trying to build a web application, you want to see how it can be deployed on a basic infrastructure, you need to firstly create that infrastructure. And this was a massive undertaking. It required a lot of thought, it required a lot of capital, it required a lot of work. So as you can see in the diagram below, we would firstly have an application, we would have to set up an infrastructure, and then the deployed application can be accessed by the required target audience. It could be an alpha version, it could be a beta version, or it could be a fully deployed application. Regardless of the workload that you are trying to target, you still would have to be somewhere around an infrastructure component on which you can deploy the application. This involved numerous complicated tasks which made things really difficult. Let's understand them one by one. Firstly, you had to understand the hardware requirements. You would have to understand the specifications of the hardware that you're going to need. What are the servers, cables, what is the electricity charges, how these things are going to be set up, what is going to be the layout of the network that you're going to create among the servers, if there are multiple servers, how the internet is going to be connected to the server, how the ports are going to be exposed, and what is the specification to handle the workload that you're trying to create. Do you need to scale it vertically or horizontally? How far away or how much support do you get for the particular hardware, so on and so forth. Since there were multiple pieces of hardware that you needed to take care of, it became really difficult for us to firstly get over this initial hurdle of understanding what cloud computing actually means. Then we move on to buying the required hardware. It's not just enough for you to understand what the hardware requirements are. You would also have to buy the hardware which is needed for the deployment. And this requires capital. This requires a lot of money, especially if you're trying to deploy it on the web. In this case, you need to have a web server that could potentially run at least 10 to 15 concurrent requests, which is a little bit more than what usual, 10,000 to 15,000, I'm sorry. But even in those small constrained environments, you have to have very powerful machines, electricity components, ventilation, so that the electricity components can run for a little longer and have a longer shelf life. Racks for the server. If you have multiple servers, you have to have a load balancer. There's a lot of infrastructure complexity that you need to take care of, and that requires a lot of capital for you to buy these things. But of course, buying is not enough. You also need to set up the infrastructure. Setting up the infrastructure involves tasks such as the cabling, laying out the structure, laying out the network topography, how the entire structure is going to be done in a way that new hardware requirements can be accommodated, scaling can be done. Again, a lot of work needs to be done there. And by the way, this is all just for a simple application that you just want to try out. This isn't even for an application that needs to be live in production under certain deadlines. Then comes configuring the system. This is also a major source of problems. If the systems are not configured correctly, they might not work well together. If two hardware systems do not have the compatible drivers, if they don't work together well, then there could be a lot of issues with that as well. Then comes managing the system. Deployment is not enough unless you have some dedicated policies of managing the system. System management really refers to how you are going to manage the system if, for instance, something happens that shouldn't have. In one requirement, you can understand it this way, that you have some data and suddenly that data gets deleted. Do you have backup systems in process? How do you have those backup systems? What those backup systems do, how often these backups are taken, what is the restore policy, and there's just a lot of complexity with managing these systems as well. So that's how these are just a few of the problems that we have mentioned. Of course, there could be other problems as well, such as incompatibility in the hardware, refund policies, processing, and a lot of other problems such as ventilation, correctly choosing the facilities where correct facilities are available, and so on and so forth. So all of this needed to be accomplished before you can deploy any application. Now that was the problem because you had to essentially give a lot of time, money, energy, manpower to this. Even if it was a small application, even if you just wanted to try something out for, let's say, for 2 hours, 10 hours, you just wanted to see if a new change that you are making to an application is going to work well. Is it going to, if you're trying to essentially, let's say that you want to speed up your application, you found a bottleneck. Now to check whether or not it is going to work, whether the speed up is going to work in a controlled environment, you need to set up some infrastructure where you create testing copies and deploy it there and allow access to some compute. This is really difficult, especially when there's no cloud computing available. So as it required significant amount of time, money, and manpower, it was not really feasible for smaller applications. So only if you had applications that could basically serve a lot of users and bring in some cash, essentially creating an infrastructure would essentially be burning the cash itself. You are not going to get any return until a specific workload is reached, and even when the workload is being reached, you need to keep the servers intact and working correctly. Any sort of major problems in the server end was going to be a really big problem, especially if you are a team of software developers who don't have much access to infrastructure components and you don't know much about setting up these components yourself. So cloud computing simply removes all the roadblocks that we have discussed thus far. These are the roadblocks that you come across when you need access to some extra computing resources. As you can see in the diagram, you can create an application, deploy it on the cloud, and then it will be deployed and will be accessible by applications. We simply removed the on-premise infrastructure components to cloud computing components. To put it simply, cloud computing refers to the delivery of computing services over a network to a remote customer. So if you are the customer, you want to build an application and deploy it on servers, instead of you having to create the server yourself, that is buying the required hardware, setting up the layout, structure, networks, so on and so forth, you can use cloud computing services over the internet to create your own remote systems and connect them together and then deploy application there. This requires significantly less money. Cloud computing offers several advantages. These are the advantages that it offers, or these are some of the advantages. I'm sure you can find more, but these are the major advantages that are important for the concepts that we're trying to cover. Let's take a look at them one by one and understand what they are. The first one is on demand. Anyone can access cloud computing services anytime they need to. Doesn't matter what time zone you are in, doesn't matter where you live, doesn't matter whether it's 10 o'clock or 12 o'clock in the morning, in the afternoon, it's 4 o'clock in the morning, whatever the time it is, you can still access the cloud computing resources that you need in order to get the job done. If this was something that this was like a privately leased hardware system where someone else has created the hardware and given you access to the resources, this would be a problem because at 4 o'clock in the morning maybe they are asleep and they don't want to run up to the server and see what the problem may be. Here you can diagnose the problem yourself anytime you want to, or create new resources anytime you want to. Before cloud computing, anyone who needed computation resources had to buy the resources and configure them, which took time. Here, if you need them, you create them. You don't need them, you can delete them, you can create them, and it works very fast. You don't have to worry about take the time that it might take for all these disposing all these resources. Scalability is also an important aspect. Cloud computing allows us to increase the capacity of resources and services, which are done quite easily. This can be done by either horizontally scaling the server or vertically scaling the servers. Now, horizontal scaling and vertical scaling are two different kinds of ways you can scale a system. Before that, scaling basically means if you have higher workloads and you want to create systems that can essentially handle that workload, or essentially you want to increase the power of the systems that you are using. There are two ways of doing that. There are two ways of essentially creating systems in or increasing the power of the system through which they can handle higher workloads. First one is horizontal scaling. Think of it scaling on the x-axis. This is a scaling in which we add more servers to our pool of servers. So for instance, let's say we had 3 servers before, all were managed by a load balancer, and as new requests came in, these were distributed evenly throughout the servers. Now 3 servers were working at the full capacity with the traffic that we're getting. To reduce the workload there, we add 5 more servers on these 3 servers. Now we have 8 servers, and they can handle the workload quite easily. The advantage here is that you can easily add or remove servers. That if you don't want to add more servers, you can stop doing that. If you want to remove the servers, you can do that as well. Then comes vertical scaling, which is basically you add more resources to an existing server. You add more RAM, you add better processing chips, you add solid state drives instead of the hard disk drives. Instead of magnetic tapes, you now have a solid state drive which does not have any moving capability, so it is very, very fast. It's expensive, but it's really fast. So you can do it either way. This depends on the use case that you have. If you only have a single server and a monolithic application, then maybe using vertical scaling is a better option. If you have a microservice application that needs to be deployed on multiple servers, then horizontal scaling might be more up your street. This depends solely on your work requirements and how you want to solve them. Then comes elasticity. With cloud computing, we can grow or shrink compute capacity as we need them. This is especially useful during the times of high traffic when we need more computing power only for a short period of time. So in cloud computing, there are ways of setting up parameters where you say, okay, in this pool of clusters, I want 2 computers to be running all the time, and at max there can be 8 computers. So 2 computers are running all the time, but as the traffic increases and the load increases on the servers, new servers should be added to the pool of servers that we have. That's basically what elasticity means. You can grow and shrink the size of your clusters quite easily. You can add or remove more servers quite easily. There's broad network access. Cloud computing services are available to be accessed anywhere using the internet. So you only need internet services to be working on a system through which you can access the cloud computing services you need to. You do not need to be on a special on-premise network to access these services, as you might need to if you're working on an on-premise system. Then there's measured services. This is by far one of the most important concepts in cloud computing. In cloud computing, all service usages are carefully measured and monitored. This allows you to pay only for services that you have used and only for the time that you have used them for. So if you used some server to be you spun up some server and used it for 10 hours, you only have to pay for those 10 hours. Sometimes it's a little more granular than that. Some services charge you per request basis. So even if you created a server that runs for 10 hours, but only 5 requests came in, you only have to pay for those 5 requests. Now, depends on the services that you're availing, and we'll take a look at that, but everything is measured and you are charged according to that. Then comes multi-tenancy. This allows different users to have access to the same cloud computing resources. This allows cloud service providers to use a single machine to service the needs of multiple users. Although these may have access to the same resource, they do not have unauthorized access to each other's data. This is done using virtualization, in which you have a very powerful machine. You break the power of that machine into multiple small virtualized machines, and one virtual machine should not be able to access other virtual machines. That's usually done using hypervisor, and we'll take a look at that as we go along. And then comes resource pooling. The provider's computing resources are pooled to serve multiple customers using multi-tenant model. Different resources are dynamically assigned and reassigned according to the customer's demand. If the customer needs more cloud computing services, let's say they need more servers, the new servers are spun up immediately and added to the pool of your servers. Instead of you having to buy new servers, add them to your remote location automatically, new servers are created out of the already existing places and new servers are added there. So it's quite useful for you in that regard as well. So these are some of the advantages that we have discussed. These are the core cloud computing concepts that you should be aware about, the core advantages. I'm sure you can add more to them, but these are the things that you should be aware about. Be aware about the terminologies that we have used here, such as on-demand, scalable, and elasticity, broad network access, measured services, multi-tenancy, and resource pooling. These are important for you to understand because these are broadly the nomenclature that is used inside the cloud computing world. Now let's move ahead and see what else we can learn. Cloud computing roles. These are the roles that you can take on when you're working in the cloud computing industry. There are four main cloud computing roles which you need to be aware of. These are provider, customer, partner, and broker. These are the terminologies that are usually used in cloud computing, and you should know what the person means when they are using these terminologies. Let's take a look at them one by one. Firstly comes provider. Provider offers cloud computing services for sale to third parties. So if you have a third party provider through which you can think about this way, if you have a provider which can provide services to the third party consumers, so essentially things like Amazon Web Services, Azure Cloud Computing Services, Google Cloud Provider, IBM Cloud, Oracle Cloud. These are the providers. They provide you services and they charge you for those services. Then there's customer. The customer purchases the cloud computing service from one or more providers. So a customer could be a software developer, could be an organization, could be the DevOps team, could be any other kind of team. What they do is that they purchase these resources from the cloud computing providers, and then they pay for the things that they use, and they set up the infrastructure and so on and so forth. Then there's cloud partner. Cloud, these include service monitoring, etc. There are several services that offer to essentially note the incoming traffic on your cloud computing providers. And if there are some bugs, if there is some error that is logged and it is appearing more times than often, then an email is issued to you saying that your website has been facing some sort of an error. Please check. And these services are usually very famous with working with large infrastructure based software. So for instance, if you are running on a huge cloud computing infrastructure where the chances of errors are quite large, then these services come in quite handy. Services like dashboard services, visualization services, so on and so forth, are all part of cloud computing partners, which are the third party companies that we have just referred to. And then comes cloud computing broker. A broker basically manages the cloud services and negotiates a relationship between the cloud providers and the cloud consumers. If you don't want to deal with all the hassle of getting the cloud computing companies understanding and comparing their services, and you want to offload that task to someone else, a broker is the person who you can contact for that. So these are the different roles that you should be aware of. Cloud computing building blocks. We'll take a look at what are the building blocks that allow us to build things in cloud computing. These are the bare minimum things that you need to understand to work with the cloud. Many services are built on top of these building blocks, so it's important to understand them. To understand cloud security, what is the most important thing to understand is that we understand the basic building blocks of cloud computing. These building blocks are nothing but the infrastructure services that make up the various cloud computing platforms. These platforms are built on top of these services. That's why they're called building blocks. Let's take a look at them one by one. So these are the five major building blocks: compute, storage, networking, databases, orchestration. Let's take a look at them one by one and how they are different from each other and what do they entail. The first one is compute. Compute services refer to the creation and management and usage of virtual servers, which we then use to perform computation tasks. These servers can then be used by users to offload some resource-intensive tasks, such as calculation or application deployment. An example of this is Amazon Web Services EC2 servers. EC2 stands for Elastic Compute Cloud. There are two C's after E, so that's why it's called EC2. It could have also been called ECC, but EC2 sounds better. What this basically means is that you can spin up your own virtual servers and you can either offload some important tasks, such as install a system software that you want to test out on a virtual server, so that even if the server gets destroyed, some things happen that make the hard drive corrupted, you don't really have to worry about it since it's a virtual server in the web. So anything that happens, not your concern. Similarly, if you want to offload some heavy computation tasks such as machine learning tasks and so on and so forth, but you want to do it on a raw virtual machine and want to go through the entire process, you can set up a computation server for that. Or if you want to set up the infrastructure to deploy an application, you can do so as well. Once you have created a virtual server, you specified the parameters that you want to create the virtual server with. That is the operating system you want, the version of the operating system, the drivers you want to install, the RAM, the hard disk, so on and so forth. Once that is done, then the server is yours. You log into it, you do whatever you want with it, then you log out with it. You shut down the server, you start the server, you manage everything about that server yourself. So these are the computation resources that you can use. Then comes storage. In cloud computing, storage is broken into two categories, block and object. First one is block storage, in which we get a chunk of storage space allocated to us, which is then partitioned into drives and managed by the operating system. This is called for example, it is the AWS Elastic Block Store. Uh, a good way of understanding is when you have worked with a hard drive yourself on an operating system where you partition it into simple drives, simple logical partitions, such as the C drive, the D drive, and the E drive in Windows. That's essentially how you can work with the AWS block store, Elastic Block Store. You can create a block of your own size, of your own specifications, and then you can use it to store some data. Second one is the object storage. Now, the object storage is a storage which abstracts the fine details of file storage and management. All these details are handled by your cloud service provider. All you have to do is upload and provide the parameters that provide the access to a file. So for instance, if you want a certain file to be accessed only via the internet, certain files to be accessed only via the file transmission protocol, and certain files to be inaccessible to anyone within a specified IP range, all of this is available using AWS S3 and other services like that. S3 stands for Simple Storage Service. Essentially, you can store all kinds of files and things as you would store inside an entire hard drive. The only thing that's different is that how it is stored on a hard drive, how the hard drive is managed, all of those concerns are not yours. You just need to add these things on a particular storage bucket that you create, and that's about it. You don't have to worry about much else. Then comes networking. In cloud computing, networks allow users to connect several other systems together in the cloud. If you have two servers and you want them to be able to connect to each other and have some sort of back and forth in a secure environment, networking is something that is needed then. Networks in cloud are highly virtualized to provide high degree of flexibility in designing the networks to suit their own unique business requirements. So, for instance, if you're working on in an organization where you have come up with a very unique and a very different kind of a structure for your networks, but you want to connect different systems to each other with a lot of complexity, of course, these complexities cannot be expected to come out of box in any kind of cloud computing service, since these are specific to your own use case. Virtual networks allow you to do so. You can create your own routers, you can create your own systems, you can create your own layout, topology, so on and so forth. And all of that is done using cloud computing, which is very useful for you. Then comes databases. In cloud computing, users may choose to either build and manage their own database servers on top of existing infrastructure provided by cloud service providers. However, it is more practical to use a managed database server. A managed database server is basically where you don't have to worry about the database server's management yourself, but the server is managed by the cloud service provider. These are example in which you don't have to worry about you just have to specify the preferences such as the database vendor, server capacity, version of the software, etc. A good example of this is AWS's RDS. RDS stands for Relational Database Service. There are other kinds of services that provide non-relational databases. Even in AWS, there are services that can allow you to do so. Managed databases support various kinds of databases, which make them more flexible than self-managed database servers. So, for instance, if you have a managed database that can support various kinds of databases, and it's more flexible for you to use them than you separately managing these servers yourself. So again, depends on the use case, depends on the kind of control and flexibility that you want in your systems. If you want full control, then maybe creating your own server, adding your own software that you want to add and then exposing it yourself is a choice to go with. However, if you want to be a little more pragmatic and you don't want the servers to work on their own, then maybe using a managed database service is a better option. It really depends on your use case. Finally, there's orchestration. Orchestration basically means when you're spinning up and managing cloud computing resources, it can get really, really difficult when you're doing it manually. For few services, it's fine, but for let's say that you have laid out an entire artificial structure there. You want to add three servers, you want to connect them using a virtual infrastructure or a virtual networking server. Then you want to connect all three of them through a load balancer, and I want to add a fourth server that is database that is connected to all three servers but is not accessible via the load balancer. This is a complicated structure, and you have to then go to the dashboard, create the three servers, add them to a pool, then add a load balancer, connect them, add a database server, connect them. This is a lot of work. And we have only added three servers and one database server and one load balancer. Many real world applications have much more complicated servers, much more complicated layouts. And this is not even considering the fact that you also have to manage these servers, that in login, check the logs, figure out if something's wrong, so on and so forth. Cloud orchestration allows us to automate the workflow of creating managing cloud environments. Here you can specify, I want three servers to be running all the time and four servers to be added at most when the traffic spikes. This will be done automatically by the cloud computing services, so you don't have to worry about it. Using cloud orchestration, we can quickly and easily create cloud resources, shift operations between environments, and perform various other administrative tasks. And we can automate a lot of these tasks ourselves. This is what makes it so important and so useful. So these are the five cloud building blocks that we have covered thus far. It is important to note that these are not the only services offered by cloud computing platforms. You can, however, build other services out of them. So that is to say that all the other services that are offered by cloud computing services are usually built on top of these services. So for instance, when you get another managed service, that is going to be an abstraction over how you can use these services. And that's really useful. Cloud reference architecture. Architecture is an important concept in cloud, but how do you architect an infrastructure or an application in cloud? Well, there are several reference architectures that you can take a look at in order to understand what are the good ways and the bad ways, what separate the good cloud architectures from bad architectures. So the International Organization for Standardization, also called ISO, publishes a cloud reference architecture in the document. The document name is ISO 17789. This document lays out common terminologies and frameworks that assists different parts of communication about their roles and responsibilities. So for instance, if you are a cloud broker, what are your responsibilities? If you're a cloud provider, what are your responsibilities? And if you're a cloud customer, what are your responsibilities? The contents of this document can be broken into distinct topics. These are the topics which include cloud computing activities, cloud service capabilities, deployment models, service categories, shared considerations, and emerging technologies. Let us take a look at them one by one and understand the basics of cloud reference architecture so that you can architect your own solutions when the need be. The first thing that we have to take a look at is cloud computing activities. So there are several kinds of activities which can be performed in the cloud computing environment, which are broken into 5 layers or 4 layers, plus a set of functions that span across the layers. So these layers are user layer, access layer, service layer, resource layer, and then comes the multi-layer functions. This is the set of technologies that span across the layer and can be used by any layers out of the 4 that we have discussed thus far. Let's take a look at them one by one. The first one is the user layer. The user layer is the user interface through which a customer or cloud computing service customer interacts with the cloud services provided by the cloud computing service provider. Performs customer related administrative tasks and monitors cloud services. So these includes dashboards, buttons, administrative interfaces where you can add and remove clusters, add them to create a new cluster group, add new servers, spin up new servers, all of that. That's the user layer. You can also think of it as the layer that your user interacts with. Any layer beneath that layer is not the concern of the user, and they shouldn't have access to that as well. Then comes the access layer. Access layer is actually one of the most important layers in the entire cloud computing activity stack. That's mainly because the access layer provides common interfaces for both manual and automated access to the capabilities available in the service layer. So what kind of user should be able to set the policies that tell it that tell the access layer how the entire system should function, what user should have access to what resources inside the service layer, and what services should be available to what user using the service layer. Access layer determines whether a user is authenticated and authorized to do a particular task or not. This is really an important task because in cloud, the access layer is very complicated. You not only just have username and password or roles, you also have permissions, responsibilities, how a particular permission can be added and removed. You have user roles, you have user groups. There's just a whole lot of things that you need to consider. So the access layer is actually very important in cloud computing. They provide the authorization needed for the users to access services inside the service layer. Then comes the service layer. The service layer contains the implementation of the services provided by a cloud service provider. The service layer contains the controls of these and the software components that implement the services. So, for instance, things such as Elastic Compute Cloud, which is the Amazon Web Services way of creating new servers.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Users can interact with the user interface to create and dispatch commands to create new servers. Then the entire process of finding a idle server, connecting the user to it, spinning up a virtualized server, adding things on top of that server, and then providing user access with that. All of that is done using the service layer. Service layer contains all the policies and the code that is needed for spinning up new services and assigning assigning accesses to the users. These services are not restricted to just spinning up servers. You can also spin up managed databases, deployment pipelines, and many other kinds of services available by a cloud service provider. Then comes the resource layer. This is where the resources or the bare metal resources reside. These include hardware such as servers, networking switches, routers, storage devices, software that runs on the hardware such as host operating systems, hypervisors, etc. So this is the lowest layer that you can go to. This is the actual data center where the entire servers are hosted. These data centers have a lot of resources that need to be connected in a specific way for the systems to work. The software also comes under the resource layer because it is managed by the people at the data center. Things such as operating systems, hypervisors, patches, so on and so forth. So this is what the four layers that we need to be aware of are. There's also another group of technologies that spans across the layer called the multi-layer functions. Multi-layer functions include functional components that interact with functional components of all the above four layers. They provide supporting capabilities such as integration capabilities, development support capabilities, so on and so forth. These are mainly used by the layers in themselves. So for instance, if one layer wants to integrate with another layer or a third party plugin, multi-layer functions contain all the services and code that needs to perform the tasks. Integration, development support, so on and so forth, all is done using multi-layer functions, and they can be accessed by any layer, any of the four layers that we have discussed thus far. Now comes cloud service capabilities. What are the different kinds of services that cloud can tender to? Let's take a look at them one by one. There are different types of capabilities that we can acquire using cloud computing services, such as application capability types, platform capability types, and infrastructure capability types. Let's understand them one by one. The first one is application capability types. There are several applications that are offered to be used by cloud service providers. such as the Outlook Mail, Google Drive, Gmail. These are all applications that are running in the cloud that use cloud technologies that are served to you via the internet. So these are the application capability types that you can use for your own benefit. Then comes platform capability types. These are the cloud services that offer us pre-configured platforms to deploy and manage our own applications, such as AWS Elastic Beanstalk. If you have ever used AWS EBS, EBS stands for Elastic Beanstalk. The reason why it is so popular is because it provides a pre-configured hosting environment. All you have to do is specify the requirements that you need to have for a platform, such as the software, the operating system, the version of the software that you want to be installed, the configuration that you need for that software, and that's about it. You can also specify the deployment steps, such as firstly, copy all the code in one particular directory, then run these tests. If the tests pass, then run the application and deploy it. And after deploying, send an email to me saying that the deployment was successful, so on and so forth. Finally comes infrastructure capability types. These are cloud services that offer us basic infrastructure tools such as servers, storage drives, and so on and so forth, which we can configure and use according to our own needs. A thing to understand here is that even though these capability types are really useful, it can be a bit cumbersome to just use them given the fact that higher level technologies are available. So for example, if you're trying to deploy an application, you shouldn't be meddling with creating servers, creating database servers, installing database softwares, connecting them using virtual environments, and so on and so forth. You can do it, but it's just an exercise in futility, mainly because there are already platforms available for you to do so, such as the ones that we have discussed thus far, which include an AWS Elastic Beanstalk. Similarly, if you want to create an application that can handle your emails and storage capabilities, then Google Drive, Gmail, Outlook, Mail, so on and so forth, OneDrive, they're all available for you to use. So instead of buying infrastructure such as the servers, storage systems, and so on and so forth, and creating your own services, it's just not something you should do unless you need certain capabilities that are not provided by any of the above mentioned services. Now comes deployment models. There are different ways of deploying different kinds of applications. What are they and what do they mean? Let's take a look at them. So there are four cloud deployment models. These are the four kinds of cloud that is available for you to deploy your applications on: private cloud, public cloud, hybrid cloud, and community cloud. Let's take a look at them one by one. First comes private cloud. As the name entails, it is the cloud computing infrastructure created for an organization and created by or for an organization for their own use. So it could be that the organization has the experience and have created the environment for themselves, cloud computing infrastructure for themselves, by buying server and setting up an on-premise cloud computing net environment. Or it could be that they have hired some cloud computing consultants who bought the resources and were given the budget to do so, and then they created the entire cloud computing facility for the organization. In either case, it's only the people of the organization and specific people of the organization that have access to these software and hardware components. And you can use it yourself only if you're part of that organization. Then comes public cloud. Organizations build massive infrastructure in their data centers and allow users to pay for and use the resources they need using virtualization. This is the easiest one to understand, mainly because this is the one that people use most of the time. Uh, Services such as Amazon Web Services, Azure Cloud Services, Google Cloud Platform, IBM Cloud, Oracle Cloud, so on and so forth, are all just extensions of this. They fall under the public cloud category because they allow you to acquire resources and then pay for the resources that you have acquired and for the time that you use. Then comes hybrid cloud. Organizations may end up using private cloud for data sensitive operations and public cloud for operations that do not have these concerns. So it could be a mixture of both public and private cloud. Some data that's very sensitive to the organization and they do not want it to be exposed in the public cloud platform. Even though it may be secure, they just don't want it to be accessible over the public internet. They just want it to be inside the privacy of their own premises. In cases like this, they can choose to store the data that they have in the private cloud that they have created, and in the public cloud they can host the applications that access the data, and that's about it. Then comes community cloud. Creating a cloud computing environment or cloud computing infrastructure can be a bit expensive. To overcome this challenge, what happens is many organizations form a consortium or a group basically to build the cloud computing infrastructure, which will then be available and be used only by the members of that consortium. So if, for instance, 3 or 4 companies come together and pool some money to build a cloud computing infrastructure, then they can all have their share of services inside the cloud computing infrastructure that they have created. Also, managing that infrastructure is going to be their own responsibility, but it's going to be their own private cloud, but not essentially just their own. It's going to be the private. It's going to be the private cloud for the entire consortium or group of organizations who have paid for it. Then comes service categories. Let's take a look at them one by one. There are 3 service categories that are available for us. First one is SaaS. SaaS stands for Software as a Service. Software as a Service basically means that using cloud computing environment, you are being given a software that you can use for your own use cases, such as Gmail, Google Drive, Outlook Mail, Yahoo Mail, OneDrive, and Dropbox, so on and so forth. These are called software as a service because you are being given a software over the internet. Even things such as Google Docs and other services such as that are software as a service, where they are providing you services over the internet that are backed by cloud computing resources. They are very popular and they are used mainly by people who just want access to some resources and don't want to fiddle with the application code. Then comes platform as a service. Users can get managed platforms where they can deploy and run their applications without developers worrying about server management. If you're an application developer and you want to deploy your application but don't want to deal with the uh, entire server management issues, such as installing new software, setting up patches, setting up cron jobs to delete the files that are no longer needed, setting up firewalls, policies, so on and so forth, Platform as a Service provides this capability. Heroku is by far one of the most popular platform as a service providers, where you just specify the application based platform that you'll be developing on, such as if you're developing a Ruby on Rails application, PHP application, Node.js application, then you can specify the build steps, which essentially just let you determine how exactly do you get from the code that you have to the deployed production ready application. What steps are there? Do you need to remove certain files? Do you need to remove do you need to add certain environment variables, so on and so forth? This is all done using platform as a service, an example of which is Heroku. Then there's infrastructure as a service, or IaaS, which is essentially just services that the users can purchase use basic cloud computing resources for their own needs, such as the servers using EC2, databases using RDS, orchestration using any of the orchestration tools that are available in the cloud, and so on and so forth. Um, these are used to essentially just work with the bare bones infrastructure services to set up your own infrastructure. Maybe you just need to do a couple of things on a particular machine and you need access to that. Infrastructure as a service is a great way of doing that. Then comes shared considerations. What are the things that different cloud computing providers, consumers, brokers, and all need to be considering when they are working with the cloud? There are several cross-cutting or shared considerations that are addressed in the cloud reference architectures. These are as mentioned below. Let us take a look at them one by one. First one is interoperability. Interoperability is the ability of 2 or more cloud services to work well with each other and exchange information. If you have a web server connected to a database managed database server, you want an application to be running on the web server, but you want that web server's application to have access to the database running in the database server. If they don't have that access, then the application that you're running will have to do some tricks in order to get data from the database server, and that won't be scalable. So interoperability is that multiple services working well with each other so that you can create an entire cloud computing application or infrastructure stack. Then comes portability. It is the ability to move data and operations from one cloud service provider to another using minimal disruption. To give you an example, if you are using Azure Cloud Services and you certainly determine that this is no longer working for you, the price is too high, or maybe the services are not as good as they were promised, you should be able to move your virtual machines, your data, and your applications or the processes to another cloud computing provider such as Google Cloud Platform or Amazon Web Services, so on and so forth. Reversibility is the extent to which cloud-based applications are designed so that they can be moved to other cloud providers or environments. This is really one of the most useful things to understand when you are working with cloud computing environments. Reversibility is basically how much of the data that can you move from one cloud provider to other cloud provider or one environment to another environment. Then comes availability that determines how much uptime can be provided by a cloud service. Basically, how much during an entire year, let's say 365 days, how much of the time is going, how much for how long is the service going to be down, so that you can essentially notify your users saying that there's going to be some maintenance in our infrastructure, our services are going to be halted in that time period. We are extremely sorry about that, but that needs to be done. How much of that is tolerated? That is what availability means. Security is also something that's very important. Cloud security involves concepts such as confidentiality, integrity, and availability. The reason why security is so important is because when you're using cloud computing security protocols, you need to maintain the data integrity, data confidentiality, and the availability of resources, as we have discussed thus far. Confidentiality basically means that the data is not accessed by anyone who should not have access to it, who are unauthorized. Integrity means that the data that was stored in your cloud computing environment doesn't automatically get changed because of some issue in the data centers or unauthorized access. Availability means that even if the servers go down, there should still be other servers running as backup servers so that I can access the data anytime I want. Then comes privacy. Privacy refers to the protection of data and activities from unauthorized access. This is a shared consideration because there are several things that the cloud computing provider can do to make your data private. Similarly, you can do several steps to improve the privacy of your applications.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Resiliency is the ability of cloud services to recover from failures and errors. What if an entire data center goes down? How is your application going to manage if an entire data center goes down? Many times, what people do is that they have several servers running in a pool of servers, and these servers are running in geographically independent location. One is running in a data center in US, other one is running in India. So, for instance, if the US data center goes completely down, the data center in India is still running, so the traffic will be moved to that one. Then comes performance. Performance is the volume of demand for resources that can be handled. If I give you some load of traffic, can you handle it? What is the performance metric for that? What is the throughput that you can provide? So on and so forth. Several things that many of the people in several roles can do in order to increase the performance or decrease the performance, such as use caching, use databases with low latencies, use cloud content delivery networks, so on and so forth. Then there's governance, which ensures effective oversight of cloud usage. When you are providing a cloud, when you are an organization who have signed up for cloud services, you need to be able to govern the entire application stack and understand how the governance is affecting your applications, how you are creating applications, how that is going to be affected by the governance. Then comes maintenance. Maintenance in cloud refers to the activities such as installing patches, upgrading systems, which may lead to some downtime. So how do you maintain the systems? Who has the distinction of maintaining the systems? How do you upgrade your systems? Is this automated? Is this automated but triggered by some user interaction, or is it manual? And how do you do this? All of this needs to be understood by the cloud computing providers as well as the customers, and so on and so forth. Then comes versioning, which is done to keep older versions of data available in the cloud to determine the stream of changes that led to the current state. It could be that some data does not need versioning. For instance, database systems, unless they are temporal databases, you may not need how the data changed from one step to another. However, things such as files and sheets and so on and so forth need this versioning capability. It basically means that if tomorrow one user logs in, makes some changes, and then leaves, the other user should be able to see what the data was before the change, what the data is after that change. Then there are service levels, which determine the values of the metrics that the cloud service needs to provide, such as availability, performance, etc. Cloud service providers need to understand what are the requirements of a user, how much availability, how much uptime, what performance are they expecting. SLA, which also stands for Service Level Agreements, is an agreement or a bond for performance negotiated between cloud service providers and the client, where you determine these are the parameters that we want in our application or in our infrastructure, and can your uh, can your services determine these, or can your services provide us these requirements? If so, then the agreement is signed, and then the cloud computing provider is bound to follow those metrics and provide the services. Auditability is used to verify the cloud service providers are fulfilling their obligations that were determined in the SLA. For instance, what was the uptime? How many times did the servers go down? How many times was there a data breach or data loss? What was the performance metrics? What was the uptime? So on and so forth. Finally comes regulations. It provides, if cloud service providers are serving customers that are under certain regulations, then their services need to be met with these regulations. For instance, governmental data access regulations in certain countries. Countries such as China have regulations which provides them access to all kind of data that is stored inside servers or data centers that are inside China. So these regulations need to be taken care of. If you're trying to deploy an application and you deploy to a governmentally regulated data center location, then your data can be accessed by the government of that country. Now let's take a look at certain emerging technologies. There are several emerging technologies in the cloud, such as the ones that are mentioned below. Let us take a look at them one by one. Hopefully you have heard of some of these, but you may not know what they are and how they are used. The first one is machine learning. It is a technique that allows machines to gain new abilities by learning from the already existing datasets. Machine learning is very popular nowadays, and many applications use machine learning. Even your mobile phones have applications that use machine learning, such as Google Lens, and so on and so forth. Machine learning is heavily used in recommendation engines as well, such as Netflix, Amazon, Flipkart, and so on. Then there's blockchain. Blockchain is a distributed data store that is used as a decentralized ledger, which cannot be tampered with and provides high level of integrity. This is especially useful for financial applications where records are kept about the transmission of data from one person to another person, transmission of money from one person to another person. People should not be able to essentially work with it and make any changes. So, for instance, if John sends his friend Brian $1,000, then that should not be tampered with, and there are several policies that are inside the blockchain consumer systems. One of the most famous uses of blockchain is in cryptocurrencies, since it's a distributed ledger, issuing new cryptocurrencies to new people, and then transmission of those cryptocurrencies from one person to another is done on blockchain, such as Bitcoin. Then there's IoT. IoT is a fairly new technology. It is a technique that is used for connecting non-traditional devices in networking, data collection, analysis, monitoring, and control of these devices. IoT stands for Internet of Things. There are several smart devices that use IoT, such as Amazon Echo, Google Home, smart fridges, so on and so forth. Then comes containers. Before containers and before virtualization was anything that we could have used, we had to create an entire server, use all the resources of that server instead of breaking even though our application may not require those resources, we still had to use them. When virtualization came along, you can break a server, a very powerful server, into simple, smaller logical servers that are using the capabilities that are inside that server. So, for instance, if a server has, let's say, 500 exabytes of data storage capabilities, then that will be something that you need to use entirely. With virtualization, you can break that up into 5 different applications. All of them use 100 exabytes of data. So containers are essentially just a step forward in this direction, in which we create lightweight ways of packaging up our entire application so that it is portable across hardware platforms. If I have an application that needs to be deployed on a Linux system, I just specify the steps that need to be followed. And once those steps are followed, then whatever environment I have deployed it on, these steps will be followed and my application will be running. Containers are very popular in microservice-based architectures and are used heavily by companies such as Netflix. Finally, there's cloud computing. Cloud computing is an emerging technology that allows substituting a traditional bits or binary digits with quantum bits or qubits as they're called for faster processing. Cloud computing is usually used only for research purposes, mainly because the technology is still being worked on. Although Google and Amazon Web Services have shown how cloud computing of quantum computing is quite superior to traditional ways of computing, but it could be a little difficult to understand how quantum computing works in general unless you have a good understanding of quantum physics as well. So just keep that in mind when you try using quantum computing. This is why usually researchers use quantum computing, because they have a deep understanding of the concepts. Cloud computing security concepts. So there are 6 key security concepts relevant to cloud computing. These are cryptography, access control, data and media sanitization, network security, virtualization security, and then there are certain common threats that we need to be aware of. Let's take a look at them one by one. First one is cryptography. Cryptography is a very famous concept, not just in cloud, but any kind of security that you are into. In cloud computing, cryptography plays a major role in data security. Some important aspects to consider are encryption, key management, data in motion, and at rest. Let's take a look at them one by one. Encryption is the process of encoding information to make it impossible to understand the encoded text. This text is encoded using a special data key called key, which is what is used to convert it back from the original to the original information, which is called decryption. Basically, imagine you have some sensitive information and you want it to be sent to a person, let's say your friend, but you do not want the people who are in the process of transmitting the data from one place to another to be able to open it and then view the information. In cases like this, what you do is you use encryption, in which you use a process to convert the data that is understandable into some format that is ununderstandable, that you can't understand what it's inside, it's completely gibberish. That process is called encryption, and there's a special finite bit of data called key that is used inside for that process. If the user if the person on the other end has access to that key, only then can they decipher the data. Deciphering basically means converting the encrypted data to its original format. So if your user has the access to the key, if your friend has access to the key, then they can take a look at the gibberish that was sent by you and convert it back to the original data and understand its meaning. Key management refers to managing of cryptographic keys within the system that uses cryptography. It deals with generating, exchanging, storing, and replacing keys as the user level. Essentially, key management allows you to generate new keys and use them, or replace old keys and if they are no longer needed. This is a complicated process, and there are several systems that do it for you. Then there is data in motion and at rest. Depending on how the data is being used, different cloud computing providers determine different security policies. Data in motion basically means data that is being transmitted over the internet or is being moved from one server to another. Data at rest basically means it is stored and is not being used by anyone. Both of them have different ways of being intercepted, and unauthorized access can be gained. So you need to understand how to encrypt and then send the data. Data at rest is not really that important or not really that complicated, mainly because you can just encrypt the data, manage the key in some way or the other, and then keep the encrypted data on the disks. Data at rest, however, is a little special because even though the data is encrypted, when it is being transmitted from one location to another over the internet, some people can eavesdrop or intercept the data and understand and take a look at what it actually entails. To overcome this, using HTTPS and SSL based connections that are encrypted over the network are going to be really useful. Let's take a look at security concept called access control. Access control is a major source of security flaws in cloud computing. Access control refers to granting and revoking user authorizations over some data or services. In cloud computing, access control can be managed in several ways. However, in real-world practice, organizations tend to manage access control locally due to its importance to organizational informational security. This is done so that the organizations have full control over granting and revoking access to cloud computing services and data. To give you an example, let's say that you are an organization who have bought services from Amazon Web Services. You now have the access of creating new cloud computing credentials, giving it to the users, and then essentially adding and removing permissions. So if you're giving some cloud computing credentials to a database administrator, all they should be able to do is they should have full access over the database. They should not have full access over any other cloud computing services such as servers or distributed environments, so on and so forth. Similarly, an application developer should only have read access and write access to a database, and thus should not have access to the database in the way that they can delete the data that they should not have access to, and so on and so forth. So these are kind of the ways that you can take a look at access control. Usually organizations like to have the access control management at their own level so that they can add and remove permissions from a particular user, they can apply permissions to a particular user group, so on and so forth. And there are dedicated services on cloud computing platforms such as identity and access management services that allow you to do so. Now let's take a look at data and media sanitization. Data and media sanitization refers to dealing with encrypted data when being erased, changed, or overwritten. When dealing with secure and encrypted data, there are several concerns that we need to be aware of. For example, we may have to delete or overwrite a small piece of data that is encrypted using a key. If the key is only used for that data, then it can be removed quite easily and there won't be much hassle about it. But for security purposes, all cryptographically secure data should be deleted or overwritten in such a way that it cannot be recovered successfully. Cloud computing providers need to take a special care for that. For instance, if you're using a virtual disk, for example, and sensitive information, then you delete the data and then you delete the disk.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It is recommended that you always delete a virtual disk once you are done with the sensitive data that you have, and you also delete the data for security purposes. After deleting the disk, there should be no way of recovering it. Make sure that you have not taken any backups or snapshots that you do forget to delete. And that's the things that you need to do on your end, on cloud computer or providers, and they should be deleting the data as they're getting it. They should not be storing it and then telling that that was deleted. Then there's network security, which is another concept in cloud computing. Network security allows us to impose restrictions on incoming and outgoing traffic in a virtual or real network. Cloud computing allows us to create our own networks using virtual networks. So many cloud services provide several tools which can be used to better protect our virtual networks in the cloud. For example, we can use network security groups for applying specific security rules on a group of resources. Firewalls should be properly used to prevent unauthorized access to our networks. Firewalls are really underused in many of the cloud computing networks that people create. So you can set up rules that these are the services that should have access to this particular server. These are the network or the IP ranges that should have access, and these are the IP addresses that should not have access to it. You should also set security rules only to grant networking access to resources that need them. That is also called granting the minimal required access. Only grant access that is absolutely needed. So for instance, if an application developer only needs access to read the data from a database and not be able to write to it, do not provide access to write to the database, only provide access to read from the database. Now let's take a look at virtualization security. Virtualization comes with its own set of security concerns, as virtualization deals with hypervisors and operating systems, host operating systems, as well as we need to be cognizant of several flaws in their security as well. A virtual machine attached to a hypervisor is affected when the host hypervisor has been compromised. So for instance, if I have a virtual machine running on a Windows system, if the Windows system that I am using is compromised, then the person who has access to that operating system may also have access to data and resources running inside my operating system in the virtual environment. So that needs to be understood correctly. Even when we are using containers, you have to be cognizant of the security concerns. It is not that since containers are a little lightweight version of virtualized environment, we should be able to understand that we are not completely letting go of security concerns there as well. Common virtualization security threats include denial of service attacks, which are also called DOS, host traffic interception, and VM jumping. Now let's take a look at certain common threats in cloud computing. The Cloud Security Alliance has defined 9 of the most common threats, security threats in cloud computing. They are also called the Notorious 9 by the CSA. These are the ones that we have mentioned below. Let's take a look at them one by one. The first one is data breach. In simple terms, data breach refers to the situation where a user or a person gains access to unauthorized information that they should not have access to. So for instance, when the data is leaked on the internet, such as some records, some Excel file, some database files, so on and so forth, and people who should not have access to the information gain access to it, that's what's not useful and is called data breach. Then there's data loss, which means that people end up losing their personal or valuable data on the cloud computing platforms because various reasons. And if you have not created any backup for the data, then the permanent loss of your data is imminent. So to overcome this, usually create good backup strategies, backup every 10 hours, every 12 hours, every day, so on and so forth. Then comes insecure interfaces. We may expose several APIs to allow integration with customers on-premise system, and therefore we need to have proper authentication and authorization mechanism in place. If we have certain APIs that are interacting with some off-site servers or off-site systems, then proper policies should be set up and how the authorization and authentication systems are going to intervene if unauthorized access takes place. Account and service hijack. Attack methods such as phishing, fraud, exploitation are used for gaining access to user credentials, and therefore their accounts become compromised. There should be proper policies in place to determine the authentication of a user, such as two-factor authentication or multi-factor authentication, so that when the user tries to log into their system, they need to have access to a certain device from which they can give us some code and determine whether they are who they say they are. And the hacker should not be able to use their account even though he or she may have their username and password. Then comes DDoS and DOS attacks. They stand for denial of service and distributed denial of service attacks. Basically, a large volume of traffic is sent to your resources, so in order to get them congested and freeze them, and other legitimate users are not going to be able to access these resources. Give you an example. Let's say that you have a website that is running on a web server, and a large volume of users start requesting your web server can't handle and becomes overwhelmed with the number of response requests, and the people who should be able to access the resources are not gaining access to that. DOS stands for denial of service, in which one particular server or one particular network of computers are sending the request. The distributed denial of service means not just one person or one network, but people from different geographical location are sending those requests, and the large volume of requests is being received by a server. Many technologies have come to determine whether a denial of service attack or distributed denial of service attack is taking place by analyzing the IP address, geographical location of the networks that are requests that are coming in, so on and so forth. Then comes malicious insiders. A malicious insider is a current or former employee who has or had authorized access to organization's network, system, or data and intentionally uses or misuses that access to negatively affect its security. If you are working on a private cloud system and an organization lets go of an employee who still has access to the information, that they can log into your system and can perform certain tasks that they shouldn't really be able to. Then there's abuse of cloud-based services. Many malicious users can end up using cloud-based services, spin up their own servers, create a cluster of servers, and launch a denial of service or distributed denial of service attacks to some other user, or can use brute force attacks to guess someone else's user credentials or password. Then there's shared technology vulnerability. Since cloud providers use virtualization, if any host system becomes compromised, then multiple virtual systems become compromised as well. Good hypervisor security and host operating system security needs to be in place in order to prevent against these kinds of vulnerabilities. Finally comes insufficient due diligence. If an organization using cloud computing services does not take care of the security concerns themselves or are not cognizant of the security concerns that they should be taking care of on their end using techniques such as encryption, security monitoring, etc., then an attacker could easily exploit those loopholes if they are aware of it. Secure cloud computing design principles. There are 5 key principles relevant to secure cloud computing. These are security lifecycle, business continuity and disaster recovery planning, cost benefit analysis, functional security requirements, and security considerations. Let's take a look at the first one, which is cloud secure data lifecycle. And the secure data lifecycle has 6 key stages in cloud data lifecycles. These are create, store, use, share, archive, and destroy. Let us understand them one by one. In creation, which is the first stage, the data is being created by one or many cloud services, such as logs being created when you add some data to a spreadsheet. That data is being stored somewhere, and that's what the cloud security lifecycle is talking about. Then comes store, which allows you to store the data that after the data is created. So once the data is created and the user clicks submit or some action takes place, that data is sent to a web server that stores it in some place. The storage can be taken place at a database, a file system, an object store, wherever it can be. It is in this stage, data is at rest and is stored in cloud computing platform. Then there's the use stage in which the stored data is then accessed once again by the user, such as a to-do list that was saved is now being retrieved by a cloud computing service provider. Then comes share. Many times data is shared among different people with different levels of authorization. For instance, when you're using Google Drive, you can share the files with different people in your own organization with a specific email or with everyone that has access to it. You are the person who sets the authorization levels and the policies that need to be done with that. So that's basically what share means. Different people should have different authorization policies attached to different files. Then comes archiving. In this stage, the data is used or accessed very few times, and latency can be tolerated for lower cost. So if you are storing some data that you are going to access once a year or twice a year, then you don't really need to store it in the hot tier of the data store, mainly because it's going to cost you a lot more and you're not accessing it that much. The times that you do access it, the access is going to be a little slower than the usual time that it takes to access the data, but that should be okay. Then comes destroy. Finally, data is destroyed and should not be recoverable from these operations where data is stored. So once the data is destroyed, it should be removed completely and should not be recoverable from any of the places where the data was stored. Preferably, if it's stored inside a virtual environment, that virtual environment should be destroyed and no backups should be kept of that virtual environment to reduce or remove the chances of recovering the data. Then comes disaster recovery and business continuity planning. In cloud computing, two major design concerns with respect to data are disaster recovery and business continuity. Disaster recovery is essentially the plan of action that needs to be implemented when a disaster strikes, such as a loss of data, data integrity violation, someone deletes the data, someone changes the data, data center goes down. Could be multiple reasons, could be a lot of reasons that these disasters strike. So what exactly do we do when something like this happens? There's also business continuity, which basically means that once the data is lost, how do our applications, how do our business processes keep on functioning? It is the objective of disaster recovery systems to ensure that business continuity and prevents organization from suffering substantial damage in the forms of losses of revenue, reputation, market share, etc. An example of this would be, let's say that you have a large database with thousands or millions of records and you delete it and the database gets deleted somehow. What steps can we take, because this kind of database takes time to restore and in that time we may be suffering huge losses? Are there any backups that are a little outdated and may not have some of the information but can keep the application running for majority of the people? Then that should be done. These kinds of processes need to be determined in this stage. For business continuity, there are two major success factors. Firstly is understanding what responsibilities are yours and which are the responsibility of cloud service provider, such as backing up the data can be your responsibility, setting up the backing up policies can be your responsibility, but the actual process of backing up and dealing with failures is the capability, it determines the capability of a cloud service provider, and it's the responsibility of a cloud service provider. And we need to clearly state and prove the cloud service level agreement components are covered and their depth coverage. So, for instance, if you have a particular backup policy set and that was not something that was run by the cloud service provider. For instance, you want the data to be backed up every 8 hours, but the data was not backed up for 2 days, then that's a violation of service level agreement, and the cloud service provider is liable then to pay you some kind of a damage recovery fee. But that's all covered in a service level agreement that you have signed with the cloud computing provider. Then there's cost benefit analysis. Cost benefit analysis plays a major role in deciding the security concerns and the solution. Cost benefit analysis allows us to compare different platforms on the basis of expenditure needed for a service that with the value provided by the service. Cost has often been called the key driver for whether an organization will adopt a cloud computing technology in some capacity. Think of it this way. If you want to protect your systems from certain cloud computing threats, you need to have certain capital with you in order to ensure those things. For instance, backing up data takes some time and money. Buying server softwares and patches that prevent certain security loopholes also takes some money. And if you don't have that kind of money, then maybe you won't invest in all of those. Then you need to weigh the systems, the pros and cons, and understand what kind of threats are more imminent to you and pay for reducing those threats or removing those threats. Different cloud computing solutions provide different services at different price rates, and they need to be thought of thoroughly before we choose the best option. Then comes the functional security requirements. Functional security requirements in clouds are the portability, interoperability, and vendor lock-in. Portability, as we have already discussed, is the easy and secure moving of data from one service to another service. If I have a server and a database and both need to have access to each other, then are they able to do it? That's essentially portability. If I want to move my data from one server to another server of another service provider, such as from AWS to Google Cloud Platform, am I able to do it, and with how much effort is it doable? Then comes interoperability, which basically means multiple services are being able to access and manipulate data securely. I have 3 servers and 2 database servers. Application servers are able to take a look at the data inside an database server and are able to access it and modify it if they need. Finally, vendor lock-in, moving encrypted data from one cloud service provider to another cloud service provider securely. Now, if vendor lock-in is not taken care of, then you get locked into a vendor's services, and now you are not able to move data from one service provider to another. So this kills the portability and interoperability of the entire server, and you can only store data in a particular service, and that service only can use it. That is going to be really, really difficult and really problematic. So you need to understand how to deal with that as well. Now comes cloud categories for security considerations. These are the 3 kinds of security considerations that you need to be aware of. Depending on the service models that you have, which are the ones that we have discussed below, you have different security concerns. The software as a service, the security concerns that we have mentioned are: is data being encrypted and when it is being transmitted over the network? Are we protecting our applications from common attacks such as SQL injection, cross-site scripting, cross-site request forgery, so on and so forth? Are proper measures in place in case of application security being compromised? All of these things need to be thought of when we're building a software as a service for our users to be able to use. For platform as a service, are we using the latest version of a platform service? Are the softwares that are being used by the deployment system updated, and are they containing the latest security patches? And is the deployment process using the latest security standards such as HTTPS and so on and so forth? It is to be noted that these are not the only security concerns that you need to be worried about, but these are the most prevalent ones. You can take a look at more security concerns and how to mitigate them at your own pace. Then comes infrastructure as a service. Are all the networks properly configured? Are proper backup and replication strategies in place? And do the host machines have the latest operating systems and security patches installed in them? These are some of the things that you need to be worried about. Network configuration for infrastructure services, software patches for platform services, and security threats for software as a service are some of the things that you should be aware of when you're trying to build these kinds of systems. These are the kind of security requirements that you need to take a look at. These are only just pointing you in the correct direction, because depending on your security environment and depending on your requirements, you may have different security concerns as well. But these are the ones that you should be aware of in any case. Finally, let us take a look at evaluating cloud service providers. There are three major ways that you can evaluate cloud service providers. These are not the only ways. These are ISO 27017, PCI DSS, and government security standards. Now, these evaluation criteria are from a cloud security and compliance perspective. There may be other criteria such as price, etc., that you need to be considering when you're evaluating the cloud service provider. But we are evaluating the security concerns. So the ISO 27017 is a document that was published by the International Standards of Organization in International Organization of Standardization, and provides standard guidance for implementing security concerns in the cloud. Many cloud computing providers offer services that comply with these standards. If you wish to know which services providers are compliant with these services, then you need to take a look at the offerings and the descriptions. For example, the Google Cloud Platform, also called GCP, offers several services that comply to the standards. So for instance, if you are someone who wants to gain access to cloud computing service that is complying to the standards laid out in ISO 27017, in Google Cloud Platform, there are several services that are certified by ISO as they are being following these guidelines. You can also take a look at other cloud service providers and whether they follow these standards or not. Then there's PCI DSS. It stands for Payment Card Industry Data Security Standard, that needs to be adhered to by any organization involved in storage, processing, and transmission of credit card information. If you're someone who is dealing with credit card information or sensitive financial information about a person, then that needs to be handled by you. If you handle the credit card system and payment system, if you do not handle the credit card system and payment system on your own, then you do not need to adhere to these standards. Then a large fine can be levied against you. So if you do handle the credit card payments and security standards are not being followed, a huge fine is going to be paid by you once that gets discovered. The standard is only needed if you are involved in the processing of credit card payments. To give you an example, if you are someone who do not use these services, for instance, your application has nothing to do with credit card services, then maybe these services are not for you to adhere to. Most services differ to the other services for this, such as PayPal, Stripe, etc. PayPal and Stripe and other services, they deal with the managing and processing of data and information related to credit card, UPI payments, internet service provider, internet banking credentials, so on and so forth. So you don't have to be worried about how these things are being handled in the backend. All you have to do is send a request describing the money amount that you need, the user that needs to send this amount, and the account that it needs to be sent to. Then there are government and security standards. Different government agencies are subject to different security standards, which need to be adhered to by a cloud provider. For example, if you're involved in any project dealing with the US government, then there are several standards that you need to adhere to and certifications that you need to get. The most common one is the CC certification, called the Common Criteria Certification. It is to be adhered to and gotten by all the hardware and software products. And Federal Information Processing 1402, which is also called FIPS 1402, is another certification that certifies the cryptographic security in government services. So if you're trying to build some software or work with some agencies that build software for the US government, then these are two of the certifications that you need to gain in order to essentially consider your application secure by the standards. Cloud data concepts. Here we'll try and understand what are the important basic concepts that we need to understand when we are trying to talk about cloud data. So in cloud data, there are two main concepts you should understand. These are the data lifecycle and data dispersion. Both of them hold special meaning across cloud data, and they are especially useful when we're trying to discuss security in cloud of data So let's try and understand them one by one. The first one is the data lifecycle. The Cloud Security Alliance conceptualizes data lifecycle as having 6 states in the cloud. Obviously, there are many other organizations that may describe cloud data as being having cloud data having multiple stages. Some would have 5 stages, some would have 7 stages, and anything in between. The point here is that the Cloud Security Alliance has created these 6 steps so that it's easy for you to determine policies for data security in each one of them. Let us understand them one by one. The first one is create. The create data security stage is, I think, one of the most intuitive one, mainly because the name itself maps onto the concept that we're trying to tackle, which is in the state, an organization generates data either directly on the cloud or in an on-premise system, which can then be moved to the cloud. So think about a scenario where you're using a cloud software such as Google Docs or Outlook or any other kind of service that you are using in order to create some data, such as using a spreadsheet, creating a document, which could be a Word document, a presentation, whatever it might be. There you are generating data. Now, in the case that we have discussed just now, using cloud software, you're creating data on the cloud itself. On the other hand, it could be that you're using an offline software such as Microsoft Word, Office, you have created some spreadsheets and all of that. You want that to be imported into the cloud, either on the Google Drive or into the Google Docs. In any case, what you do is you get the data and you import it on the cloud. The data is created on premise, but you want that to be uploaded to the cloud, and that's one way of doing it. Depending on the volume of the data, there are several other options available. There are data that's in terabytes, so uploading it over the internet could take a long time. In cases like these, new technologies have come up, such as boxes of data moving devices that are transported to your location, from where you can copy the data and then send it back to be uploaded onto the cloud. The important thing to understand here is that if the data is being moved from on-premise to the cloud system, it needed to be moved securely, because until it reaches the cloud platform, security is on you. So make sure that you are using an HTTPS connection. Make sure that you are not using it on a public public internet service, such as a public Wi-Fi or something like that. Do not use on public networks, because there is a chance that someone could listen to or essentially intercept the data that is being transmitted from your end to the other end. But in any case, it's a good way to think about security in the creation phase. Then comes storing. Data is moved to a storage repository for retention and later use. Now, it has happened to all of us that we have created data and then we want to store it, either temporarily or for a long period of time. In cases like this, cloud services provide multiple storage options, and we'll take a look at that later in the presentation. But here what we have to understand is that during the storage phase, the data needs to be secured. Cloud computing providers take numerous steps to do so, but in our case, we could also do a bit of due diligence and set up encryption policies, so that when the data is, even if the data breach is there and some malicious user gets access to the data, they don't know what the data stands for. They can't intercept it, they can't unencrypt it, they can't decrypt it, they don't have any idea of what the information that is held inside the data is all about. It could only be accessed by people who have a valid key to decrypt the data. So that's on your part, but that's the storage stage. Then comes the use stage. Data in this stage is in active use and is being used and viewed and processed by systems. Again, there needs to be proper encryption and decryption systems in place. When the data is being accessed and being modified by the users, it should be decrypted, and once the decryption is complete and then the processes are complete, data is modified, new data is added, old data is removed, whatever the case might be, then that data needs to be decrypted again. Then there's sharing of data. Sharing is a peculiar option here, mainly because when you're setting the policies for sharing, it all happens usually inside the cloud. So you don't really have to worry about encryption, decryption policies there, but you do have to worry about how the authorization systems are working, which people have you given what permissions to do with what data. So if you're sharing some data with some person, you need to be sure that the data that you are sharing is only supposed to be viewed by the person, so the person only has the permissions to view the data. They cannot access the data, they cannot essentially delete the data or cause some sort of a change to the data. Similarly, if you are trying to give change permissions to some data, make sure that you are giving the minimum necessary permissions. These permissions include deleting the data, modifying the data, so on and so forth. Then comes archiving the data. Archiving basically means moving it from hot tier to cold tier. Or to give you a basic understanding, data usually stored in locations and redundant systems, mainly because they provide faster access, but they cost a lot more. If you have some data that you don't need to access that often, then you can move it into the archived state, in which it will be stored in locations where it's not accessed in that much of a speed. Latency is going to be there during access. However, there's not going to be that much cost for storing the data. Since it's archived, it's not used that much. You are free to use it once or twice a week, once or twice a month, once or twice a year, depending on how frequent your data usage schemes are. In any case, you need to make sure that the data is archived so that it doesn't cost you a whole lot to store the data that you rarely use. Latency is going to be there, but if the data is only used once or twice a month, then a little bit of latency is not really that big of an issue. Another thing to understand is that when the data is archived, that data is already encrypted, because if you have stored the data in an encrypted format, then the data being archived is going to be encrypted as well. Finally, there's the destroy phase, in which we delete the data which is no longer needed in a way that it cannot be recovered. An important prospect here to understand is that even when the data is deleted, there are ways to recover some bits of information. So again, only destroy data once it's encrypted, so that even when the person who gains access to the information cannot understand the data. And a better way of doing it is to, on cloud, use virtual disks to store data, and when all the data stored inside the virtual disk is removed, then delete that virtual disk as well, so as to create better security.
Just a quick info, guys. Intellipaat provides CCSP certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Concerns. Also, one thing to understand is that there are specific software systems that can do this for you, where they essentially delete the data and shred it in such a way that it becomes unrecoverable. So make sure to look into that as well once you are dealing with some ultra sensitive data. Now let's take a look at data dispersion.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Data dispersion is used to store multiple copies of data at multiple locations. In cloud, there are two ways of doing it. First is called bit splitting, second is called erasure codes. Both of them are quite popularly used in storage systems. They both have their own pros and cons, and they both have their own special way of working. Essentially, what we try to do with these is that we create some sort of redundancy. So once the data is stored in multiple locations, if one location goes down, other locations can be used to rebuild the data, or other locations can be used to provide some backup. In any case, let's take a look at them one by one. So first comes bit splitting. Bit splitting is like adding encryption to RAID. RAID stands for Redundant Array of Independent Disks. Here we store data in an array of disks, and it allows us to store data in a more secure way. Similarly, bit splitting works much more like that, but with encryption added to it. The data is first encrypted, then separated into pieces, and the pieces are distributed across several storage areas. This is so that even if one of the storage locations gets compromised, the person who has the compromised storage location cannot access the complete data. He can only access a chunk of data, which may not be something useful for them. Bit splitting carries the following disadvantages, however. Processing is CPU intensive. So once you have uploaded the data, if the data is of huge volume, splitting it and performing bit splitting on it, which includes processing intensive tasks such as encryption and chunking the data and then spreading it across multiple locations. All of this is a CPU intensive task, so it cannot be done for a lot of devices, for a large volume of data, for a lot of users. Availability concerns are all part that the data needs to be decrypted before you use the information that is contained inside the data. So you need to be able to understand that all parts of the data are available, so that when you decrypt the data, it is completely decrypted and the entire information is presented in front of you. Storage requirements and costs are higher than other systems because it takes time, it takes effort, and you need to store multiple shreds of the data in multiple storage locations. You need to have multiple storage devices all attached to each other, maybe, or maybe in separate geographic location. That's completely up to you, but that's one way of doing it. Now, here's how bit splitting works. These are the steps. First things first, we encrypt the data. This is done to make sure that the data that is sensitive is becoming data that is incomprehensible. So encryption basically uses a key and converts plain text to ciphertext. Plain text is the data we have, ciphertext is the data that we want. That's something that people can't comprehend, and it becomes something that people cannot understand. Then we split the encrypted data into chunks. Chunks are basically small pieces of same size of the data, so that we don't have to worry about how we go about splitting the data and how we distribute it. Then the data is distributed to different locations based on the chunks. If we have 8 chunks and 4 locations, two chunks are displayed on all locations. Preferably one chunk on one location is a good strategy. Then comes encryption data at new location. Once the data is put on the new location, it needs to be encrypted there as well. That is the responsibility of the local systems, or you could encrypt it on your own. That depends totally up to you. This is done for enhancing security, so that even if one person gets access to the encrypted data, it has another layer of encryption added on top of it, so that once the person breaks that encryption, even if the person breaks that encryption, it's not going to work for other pieces of data. Now, to recover the original data, the reverse of the above mentioned steps need to be taken into consideration. For example, the data chunk that was stored in a new location that was encrypted needs to be decrypted first. All of the chunks need to be decrypted. All of the chunks need to be collected in the correct order. They need to be put back together, and then the final decryption needs to happen before we can access the data. On the other hand, we have erasure coding. Erasure coding is like using parity bits for RAID stripping. In RAID, parity bits help you recover missing data if one stripped drive gets lost. So essentially, parity bits work like this. Suppose I have 4 bits I'm storing. All of them can either contain 1 or 0. Parity allows us to determine whether or not parity allows us to determine whether or not how many number of ones are there, how many number of set bits are there. If there are even number of bits, then the parity is 0, and if there are odd number of bits, then the parity is 1. There are options to reverse this, so that even number of bits get a parity of 1 and odd number of bits get parity of 0. That completely depends up to you, but you have to understand the differences between them. Once that's done, even if one of the bits gets lost or corrupted, we can just take a look at the number of bits that are set, and then we can add the data. So for instance, out of the 4 bits, I have 2 ones and 2 zeros. So there are even number of bits that are set, parity is going to be 0. Once one of the data is lost, I check again how many number of bits are there. If, for instance, I have 4 bits, and out of those 4 bits, 1 bit is lost, so I still have 2 ones. That means I have even number of data, and only one piece of data can be added there. That means the missing chunk was 0, so you replace it with 0. That's essentially how RAID works. That's something that is taught to us using in storage systems. But the basic method in erasure coding of data protection is which data is broken into fragments and then expanded and encoded with configurable number of redundant pieces and data and stored across different locations. So that's essentially how it works, very similar to how RAID and parity stripping works. Erasure coding helps you recover missing data in the cloud if the place where the data was stored becomes unavailable or the data gets lost while you disperse your data. In cloud, erasure coding is only used for cold data storage. Cold data is, as far as you are aware, is the archival storage systems. So storage systems that have low latency or high latency for lower costs. And this is because it gets very compute intensive than simple replication across geographical regions. One way to protect your data from being lost when one data center goes down or one server goes down is by copying the same bit of data across multiple regions, so that if one of the data centers completely go down, the data can be recovered from other places. Erasure code like RAID creates parity bits along with chunk data to make it easy to recover the data. A common erasure code configuration is 4+2 erasure code, which means that the data is split into 4 chunks and 2 parity chunks are created out of that 4 chunked data for data recovery. This configuration can tolerate up to 2 node failures. Both of them can either be parity bits or both of them can be data bits, but both of them cannot be parity and data bits. Now, more than two, if there's more than 2 node failure, then there's no way of recovering the data. Now, this is what the process looks like. Firstly, we create the chunk. Data is chunked into 4 parts. Then we encode the data. Encoding the data is a mathematical process in which we keep the 4 chunked pieces that we have as it is, but we create parity bits out of it as well. Parity bits let us take a look at how many ones and zeros are there so that we can understand how the ones and zeros work. Then we write to the disks. Writing to the disks basically allow us to have 6 chunks and we have them be written to 6 different disks so that the failure of one disk does not affect the other one. Now, in case of failure or corruption of data in these disks, we can use mathematical operations to rebuild the missing data. This only works if the number of lost chunks is less than or equal to 2. If it's more than that, then the data is unrecoverable and essentially our entire data is corrupted. This is why it's stored on multiple locations so that even in when worst of worst comes, only 2 of the places where data was stored can go down. Other places might not go down. There's a good chance that that's not going to happen. This is because if the lost chunks had one data chunk and one parity chunk, data can be recovered. If both the parity chunks are lost, then also they can be rebuilt using the existing data. We can just pass it through the encoding process and rebuild the parity chunks. But if both parity chunks and a data chunk is lost, then there is no way of knowing how to recover the data, and we have essentially lost the data that we needed to recover. So that's basically how data dispersion works in a nutshell. Design and implementing cloud data storage architectures. In this, we'll try and understand the individual components of cloud data storage architectures, and we'll try to understand what are the security components that we need to take into consideration when we're using these architectural components. Let's take a look at them one by one. So in cloud data, there are several ways of storing data to cater to different use cases. Using these, you can build your own architectures to satisfy your own use cases. Now, there are also several threats that you need to be aware of, which is what we'll be covering right now. So firstly, let's take a look at storage types. There are 6 main storage types available in the cloud: raw storage, ephemeral storage, volume storage, object storage, CDNs or content delivery networks, and long-term storage. Let us try and understand them one by one. The first one is raw storage. It is permanently allocated disk storage that stores data and exists independently, that is without this running server instances. Basically, you can store some data and then forget about it. You don't need to run a server and attach the disk to that server, so on and so forth. So it works completely fine. It is used to persistently store data such as logs, files, etc. So if you have some data that you need to be stored for a long period of time, raw storage is the best option for you there. Now comes ephemeral storage. Often used to swap files and other temporary storage needs, this storage type is used with infrastructure as a service instances. Basically, it is used with the raw servers, whether they're virtualized servers or real-world servers. And when the instance is terminated, that is either we shut it down or we delete the instance, our instance of the ephemeral storage gets removed with that as well. So it's only for temporary storage purposes. It's really fast, it's really cheap, and it's for temporary storage. Now they are also used as caches and temporary storage locations, which will store data as long as the server is running. So for instance, server logs and all of this kind of stuff, you can run inside, you can have them be stored inside an ephemeral storage. Now, most often a virtual hard drive is something that is attached to a virtual machine or a host. That's what a volume storage allows us to do. Basically, a volume storage is if you have some drive and that drive needs to be partitioned into separate volumes. For instance, when you are working on a Windows system or Linux system or Mac system, you have a disk drive that is much bigger for your need. So you logically partition the drive, that is create 3 separate spaces for those drives. In Windows, it's usually the C drive, the D drive, the E drive, and so on and so forth. Depends on how you have partitioned the system. So this is one of those partitions could be considered a volume, and a volume storage is often referred to as a virtual hard drive, which is attached to virtual machines and host systems. It is used to persistently store data and can be attached and detached from already running server instances. Think of it as a virtual USB drive or a virtual SSD drive. Basically, you create some data, you attach a virtual storage or volume storage to that, then you copy the data to that volume, and then you detach the volume, and now it's stored in there. Now, if the server gets deleted, also the data is remaining in the volume storage and you can use it later on. Then there's object storage. File shares accessed via the web interface or real world APIs. Real world examples include Rackspace and Amazon S3. If you've ever tried to store some really unstructured data like audio, video, images, any of this kind of stuff on the internet, then on the cloud essentially, then object storage is the storage that you have used. It is not something that creates a file system for you, and how things are managed underneath is not really a concern. You just want a bucket there to be able to throw some data inside it and then forget about it. And this allows you to do that. It is used for storing massive amounts of unstructured data using such as storing photos, songs, or files, etc. Unstructured data is basically data that has no structure to it. There's no pattern. That's nothing. That's just a stream of bits rolling around, and that's what unstructured data is, and that's how you use. That's what you use an object storage for. Then there's CDNs, also called content delivery networks. They are used to store static assets which are replicated over several locations in geographically distant locations. This is done so that your static assets can be accessed by a global audience. To give an example, let's say you deploy a website. It uses certain images, style sheets, fonts, so on and so forth. These are static assets mainly because these do not get updated regularly. They are not dynamic. Different users are not going to get different versions of these files. So what happens is, if you have a server that is serving this file over the internet, and that server is in the United States, and then you are somewhere on a distant location, let's say India, then accessing that website is going to take you a longer period of time because the data needs to travel longer distances than it would take someone, let's say, in the United States. So that's a big problem. In order to overcome this, what happens is these servers are configured in such a way that they access these static resources from the nearest servers available. And these nearest servers are also called edge locations, which are referred to as content delivery servers or content delivery networks. Many of the servers are located and spread across geographically. So one may be in the US, one may be in Africa, one may be in Europe, one may be in Asia, one may be in China, one may be in India. Depending on where you are accessing it from, the nearest server is then asked to fetch the resources so that it's delivered to you at a much greater speed. They are used to store and cache static assets such as images, CSS files, etc. in geographically distinct locations for faster access. Finally, there's the long-term storage. It is also called archival storage. It is used for storing data that is not accessed very frequently, and latency in access is tolerable for low storage cost. Think of it this way. You have some data and you don't use it very often, but since you have stored it inside cloud, you get the opportunity of accessing it really quickly, but that costs you a lot more than it should, mainly because you don't use it that much. You can have the option of moving it to an archival storage system in which this will be stored, and the time that it takes for you to access the file could be a little longer. Let's say that if it takes 1 second for it being served over the internet in the normal storage locations, then in archival it will take 2, 3, or sometimes even 4 seconds. However, that's tolerable because you only use it like once or twice a year, once or twice a month. It's not that frequently accessed, and you get a much lower cost option for storing it inside archival storage. They are used to store data at lower cost and higher lower access speed or latencies, as this data is used less frequently. Think of data such as data logs or something like that, which you use once a month to audit the security prospect of your entire network. In cases like this, these can be moved to an archival storage each year so that the previous year's logs are moved into the archival storage and the current year logs are kept so that they can be viewed at a fast speed. Then the current year, when next year comes, the current year logs are then sent to the archival storage and the new logs are recorded, so on and so forth. Now let's take a look at some threats to storage types. Storage types are an important concept in cloud computing, but there are certain threats that we need to be aware of when we're discussing these storage types. Let's take a look at them one by one. In the ISO IEC 27040 is an international standards published by the International Organization for Standardization and the International Electrotechnical Commission (IEC). The standard describes few threats to storage. These are unauthorized access, unauthorized usage, regulatory non-compliance, DOS and DDoS attacks, modification and corruption and destruction of data breaches and leakages, theft or accidental loss, malware attacks, and improper sanitization. These Let us discuss these threats into a little more detail and understand how you can prevent it. The first one is unauthorized access. As the name suggests, users gaining access or are able to view and manipulate the data that they should not have access to is called unauthorized access. To prevent this, you need to set strict authorization policies and only allow access to resources that are absolutely needed by them. For instance, if a user requests for building an application, let's say that you are an organization and the developers want access to certain resources, you only provide access to those resources that they absolutely need. So a server, a database instance, and a virtual server in which they can connect each other. That's about it. That's all you need for the usage of your app developers. Similarly, other users may have other needs. You need to firstly assess the needs and determine what are the minimal accesses that you can grant them that could work. And once the access is complete, they have done what they need to do, then access revocation policies should also be in place. Then comes unauthorized usage. Users are able to modify, update, or even delete data that they should not have access to. So for instance, if I have created some piece of information and I should be the only person who can access it and modify it, but another user comes in and can do so, then that's an unauthorized usage storage threat. That's a concern that we need to be thinking about. Now, to prevent this, granular permissions should be used and only the required permissions should be granted to the users. Many storage systems allow you to set granular permissions, such as if a user is allowed to just view the data, if they are allowed to manipulate the data and view the data, if they are allowed to manipulate the data, view the data, and also delete the data, and if they are allowed to basically they become the administrator and they are allowed to share this data with other people and can revoke my own access to this as well. So you need to understand the context in which this entire application is running and how the storage systems should be utilized there. For instance, if you have some file and you have shared it to someone, you only need to share them with the permissions that they need. If I only want to view the file, then you only need to share it with me with the viewing permission. And there are options for you to specify the time period for which I can view this. So for instance, for the next 7 days, I can view the file. I can't change it, I can't delete it, but I can view it for the next 7 days. Now comes regulatory non-compliance. Several applications deal with data that is regulation bound, such as data regarding credit cards and payment systems. This data needs to be stored in compliance with the set standards. Otherwise, there is a risk of data breach and leak, and you can be levied with a heavy fine if it turns out in an audit that you are not complying to the regulations. It should be made sure that all the regulations are being properly followed through, and tests and or mock audit should be done, so that when the audits are performed, we can get access to the information that we need in order to determine whether the regulations are being followed. Then comes DOS and DDoS. Many people know these as being denial of service and distributed denial of service attacks. These are basically network attacks in which multiple requests are sent to a particular server in order to take it down. A high volume of traffic is sent to a particular resource or particular server so that it becomes either really slow or it hangs up and dies. In any case, the legitimate users are now not able to access the resource. There are ways to prevent this, such as analyzing the incoming data for patterns such as large amounts of requests coming from the same device or a same network. You can also set policies to deal with the same. Many times, many big companies, what they have done is that they have set systems in place that will determine whether or not a particular IP address or a particular network is potentially performing some DOS or DDoS attack. If that happens, then each request from that domain needs to firstly pass a CAPTCHA test, which specifies whether or not the person whether or not a human is sending the request or machines are sending the request. Do note that this is not just enough for that, mainly because you can't just expect all of this to work just by software. There are several other softwares available for you to install and use for preventing DDoS attacks as well, but strong security policies are the major beneficiaries here. Then comes modification, corruption, and destruction of data. Data in the cloud is protected against unauthorized modification, corruption, and destruction of data. This is usually remedied using data dispersion and replication. So think about it this way: if you have some data and an unauthorized access has taken place, or maybe the data center where the data was stored suddenly crashes, goes down, some natural calamity happened, fire erupted, water came down, something happened, and the servers are destroyed. So the data that you had stored in a remote location where you have no access to it needs to be secured in such a way that it can survive these attacks or survive these calamities. One of the easiest way and one of the most preferred way is using data dispersion and replication. As we have discussed, replication basically means that you store multiple. What you do is you chunk the data into smaller pieces and then you spread those pieces across multiple locations so that they can be rebuilt again. Replication, on the other hand, is just copying the same file across multiple locations so that if one location goes down, the request for gaining access to the file can be transmitted to another server or another place, another geographical location. Data breaches and leakages are quite common nowadays. Data breach and leakage lead to data being accessed by unauthorized users who can then copy and transmit and view the data. To give you an example, when some data gets leaked on the internet, then a simple Google search will reveal the data to be available and to be used. To prevent this, we need to make sure that the sensitive data remains encrypted and HTTPS is used when data is being transmitted over the internet. This prevents data leakages mainly because once the connection is secured and HTTPS systems are being followed, then the data is encrypted over the network. So even if some person is able to essentially listen to what we are sending back and forth, they are not able to decrypt the data, and it's completely up to us to take a look at that. Then comes theft or accidental loss. If a user gains unauthorized access to the data and they can delete the data after creating a private copy of it, and the user may also end up accidentally deleting their own data. It is quite common to users for deleting their own information accidentally. There are several ways of preventing this. First one is make sure that the user is only able to gain access to read-only copies of the data so that they don't accidentally delete it unless they choose to change the mode. Know that this is not enough. Sometimes users are able to change the mode and forget which mode they are on, and if they're in admin mode, then they can delete the data easily. Also make sure that the data access is revoked by the owner or the administrator once the person is done with dealing with data. There are other things that you can do as well, such as multi-factor authentication, to make sure that the user doesn't accidentally click on two buttons and gets the job done that they didn't mean to do. They need to enter some captcha. There are many things that you can do in order to make it difficult for them to delete it accidentally. Then comes malware attack. Malware stands for malicious software, which can end up corrupting data all the resources that are stored on a particular device or on a network. So malwares are quite common, especially in cloud computing. So in order to get rid of them or to overcome this hurdle, the best way to is to install antivirus and anti-malware software on your systems and make sure that they are regularly being updated, and then they regularly run their system checks when they are running, so that once the system is being run and malwares do end up attacking, they can be easily caught and can be removed. Also, it is to be made sure that the resources are not exposed to unknown devices or unknown networks so that other people can access and install other software. Finally, there's improper sanitization. After data is deleted or delivered, it should be made sure that it cannot be recovered from any of the resources that the data was stored on. So for instance, once you download a archived copy of it and you delete the data, then it should not be possible for people to look at the cloud computing resources and recover bits and pieces of the data. To do this, you need to use proper policies to destroy data and destroy virtual disks on which the data is stored once the data is removed completely from them. Also make sure that both logical and physical deletion takes place. Logical deletion means that it's deleted from the file tables of the file system that is stored inside the disks, but physical deletion means that the actual bytes get wiped from the disk and it becomes completely clean, so that even if somebody wanted to, they can't recover the data from the disk on which we have performed the deletion. How we can design and apply data security technologies and strategies. In In cloud computing, there are several ways of applying data security strategies, so let's take a look at them one by one. The first one is encryption and key management. Encryption is the process of using some process called algorithm to convert some data from its original form, known as the plain text form, to an alternative form known as the ciphertext form. Encryption of data is done using a special random data called the key. The key is a very important concept in encryption. Encryption essentially is a branch of cryptography. It is a cryptographical process. Basically means it hides the original meaning of data. So the contents of the ciphertext cannot be understood by anyone. It appears to be extremely random, and you can't draw any information out of this. Now, the ciphertext is converted back to plain text by using a process called decryption. Decryption is the reverse process of encryption, and and it is to be understood that for decrypting the data, the user needs to have the same key that an algorithm had used to encrypt it. There are several algorithms in which you can use a private key to encrypt the data, and then public key which could be multiple keys that the person can have. So in this regard, you don't need to share the same key with the person, but in other regards, you do need to share the first key, the same key to the person, so that the process could be reversed. That really depends on you. There are several kinds of keys available for you to use, such as symmetric keys, asymmetric keys, several algorithms for you to use. There's a whole range of things that you can do. The main thing to understand here is this, that keys are important to use, but they are difficult to manage. There are key management softwares that allow this to happen for you. For instance, if you have some key and you want to manage that key, then using a key management software is a great option for you if you have multiple keys and you have multiple data files that you have encrypted. They will also take care of knowing which data was encrypted using which key, and if the data that a key belonged to is deleted, could that key be deleted as well or not? All of this is a complicated process, and there are softwares that will do it for you. Essentially, the process works like this. Plain text is passed through an algorithm and a key supplied to the algorithm. These two features are important. Then this new key that was passed in allows it to encrypt the data and convert plain text to ciphertext. Then that ciphertext, when the user wants to read the data into it, the ciphertext is again passed through the algorithm to decrypt it using the key. Now that key, along with the algorithm and ciphertext, will convert it back to the plain text. Ciphertext is some text that has no meaning. You are not going to be able to understand what it actually contains. So even if a person was able to gain access to an encrypted data, let's say that you have some data stored inside a drive, somebody steals that drive, gains access to it over the internet, whatever it could be.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
They are not going to be able to extract the information from it because it needs to be decrypted, and it's only decryptable using a certain key, which that person does not have. Then comes hashing. Hashing is the process of converting some data of arbitrary size into a shorter fixed length value called its hash. Different hashing algorithms give you different size of hashes. Usually 64-bit strings are useful, for which there are 64 alphanumeric characters strung together one after the other. Hashing gives us the same data always as a result of the same value. So for instance, if I have some data and I hash it 4 times, I'm going to get the same hash or the same string of finite size. Now it could also be called the signature of the data. Now this is something that many people, when they first understand, find it a bit difficult to understand, mainly because it's not apparent where something like this would be used. So surely you can understand that you can get some data, pass it through an algorithm called the hashing algorithm, and it will give you a signature, if you would call it that, or a hash, if you would call it that, which is a fixed length string. And if you were to hash the data again and again and again, the same hash or the same key, same fingerprint will be given to you again and again. Now, where this is useful is something called integrity management. When you have some data and you want to verify if the data has reached you correctly, then you can use hashing algorithms. Many of the online providers of software do this. So for instance, if you're downloading some really big piece of software, let's say an operating system, a disk image of an operating system, what they do is that they give you a small fixed length string, also called the checksum string. That string contains is the hash of the data that they have calculated. Now, once you download the operating system's image, you can then again pass it through the hash, calculate its hash, and then check whether its hash, the hash of the file you have downloaded, matches the hash of the file that you just copied. So then, if the hash is matched, then that means that the data has not been modified and you have downloaded the uncorrupted version of the data. If, for instance, even a single bit of information, if a 0 is turned to 1 or 1 is turned to 0, even that change is going to affect the entire hash, and it's going to give you a completely different result. So because of this, you need to understand that the hashes are really important and they are used to check data integrity. Now, another important thing to note is that hashes cannot be used to convert the back to the original data. So just as encryption, when you decrypt the data, you get the original data back. In hashing, there's no such concept. You can't unhash the data, just as you can't convert some large piece of information into a smaller piece and then convert it back to the larger piece. That's just not going to work. So that's how hashing works. Then comes masking. Masking is a very prominent technique. It's used by many online service providers. It is also called data obfuscation. As the name suggests, we essentially just hide some pieces of data that we want to be confidential. It is the process of hiding original data by modifying its content. If you have ever downloaded some official government documentation, then unless you are authorized to have that information, you will be able to download the document, but the data inside it will be masked using X symbols or O symbols or dashes or whatever. This is done to protect the data that can be considered commercially sensitive or even personally identifiable. So for instance, if it's a personal information or it's some commercial data such as the GST number, or could be anything that you do not want people outside your organization having access to. People who should not have access to this piece of information in some records are shown are as the masked data. Suppose you have some database and there are multiple people who can view the database information, since some of the database information is not something that is sensitive while other pieces are sensitive. So for instance, in the case here, the ID, name and email is a sensitive field. Now you can prevent access to the entire row itself. However, it is considered a better option to just hide the data that you don't want people to be able to recognize. So in cases like this, what you do is that you get the data and then you mask it. As you can see, after masking it, we, instead of getting john@example.com, we get the first and the last letter, and if the @ symbol is intact. Other than that, everything is hidden behind an X. The name and the ID field are not that sensitive, so you can just show them and it's fine. Although if you wanted to, you could mask those as well. If you want some data to be protected while others not to be protected, then masking is a good choice for you. Then comes tokenization. Now, tokenization is one of the easiest things to implement, and it is very easy to use as well. It is the process of substituting sensitive data elements with a non-sensitive equivalent, which has no exploitable meaning or value, called a token. Essentially, what happens is that this tokenized data can be mapped back to its original form, or the original data stored inside a token vault, which contains the tokens and the original values they correspond to. To give an example, let's say that I have an original value in which I have the ID and name column mapping to 1 and John respectively. I create some tokens. Tokens are just randomly generated things. So now the data is 1, and when we see 1 as the ID, it should be mapped to 7. Similarly, when the name becomes John, we want to map it to Brian. Now, whenever a person gains access to this data, they will only gain access to the tokenized version, and internally we'll be using the original version. The reason why this is useful is because once you are using data replacement techniques like this, even if the person gains access or hacks the information, they're going to get access to information that is completely nonsense. There's no record in our system of someone named Brian with the ID of 7. However, they're going to get it, not realizing that it's fake information, and they won't be able to make any use of it. On the other hand, we will be able to map it back to the original data, and that original data can then be used by our internal systems. So it's a good way of securing the system so that Even if there is a data breach, no one is able to access the actual data that they need to, unless the token data vault is also leaked, in which case you have bigger problems at hand. Then comes data loss prevention, also called DLP. Data loss preventions are a set of technologies that detect potential data breaches. It's not just a single piece of software, it's a group of software. It prevents them by monitoring, detecting, blocking sensitive data while in use, in motion, and at rest. Think of it this way: if you have some data and you are using it, it could be in motion, it could be in rest, or it could be in use while it's being created. These refer to the lifecycle stages of cloud data. And all of these different stages have different security requirements. Now, instead of you having to do it on your own, monitoring the data, detecting and blocking sensitive data, this can be done by data loss prevention systems. Standard data loss prevention systems use technologies like firewall intrusion detection systems called IDS, antivirus softwares, anti-malware softwares, etc. There are also some advanced data loss prevention systems which use machine learning algorithms, temporal reasoning algorithms, user activity monitoring, etc. These help in understanding how the data is being accessed, if there's some irregularities in the users who are accessing the data, and if so, that the data can be either put into a vault and prevented access unless a person gives some OTP. There are different security policies that can be put into effect after a suspicious activity is discovered. Then comes data de-identification. Data de-identification is also called data anonymization. So if someone is talking about data anonymization, it's the same thing. It is a process that is used to prevent someone's personal identity from being revealed from some data. There are moments when there are times in your life when you submit some data with your consent, with the understanding that the data is not going to be out for other people to use. Your participation in the data collection process and your data that you have provided are going to be completely confidential. In cases like this, we need to provide some mechanism to de-identify the data or anonymize the data. This is usually done when some sensitive data is collected and the identity of the person is irrelevant. For example, when the data is collected from the participants in a medical study. You might end up collecting more information such as the name of the person, the email, if they should be, if they can be essentially contacted, if there's some important stuff that we found about it and we want to call them once again for some another kind of study. Now, in any of these cases, the problem here is that when you publish the study result of the study, you need to publish certain information, and in this publishment, you need to verify and figure out that you are not leaking some personal information that you should have held back on. So, in cases like this, what you can do is you can use data de-identification techniques. Data D is de-identified after passing it through a series of steps, which uses techniques such as tokenization, masking, removal of personal data, etc. Personal data such as name, email, etc. are removed out of this. Now, several institutions and government bodies have their own rules and standards for data de-identification. So it may be that you don't have to do it on your own. Once you store the data inside some system, when you publish the results, the data that you will be given access to is going to be automatically de-identified. But in any case, it's important to understand. As the diagram shows below, a simple data de-identification pipeline in which we tokenize the data and then we mask the data and then we remove the data. So with that, now let's take a look at what else we can do. How you can implement data discovery. So in cloud computing, cloud computing is a set of technologies that can play a big role in data discovery. Data discovery is the process of collection and evaluation of data from various sources. There are several concepts that we need to understand, such as types of data, data discovery techniques, and the issues that might pertain when you're trying to do data discovery. Let's take a look at them one by one. So the first thing that we have to understand is the types of data. Data can be of several types, and discovering these types of data can be different from one another. So the two kinds of data that is available is structured and unstructured. Let us discuss them briefly one by one. Data that is comprised of clearly defined data types and patterns which make it easy to search and comprehend, e.g. data stored in tables, is called structured data. Think of data stored in your databases, your SQL databases, in which you have tables, columns, foreign keys, primary keys, and all of that. That's called structured data. It has a structure to it. You can see the structure repeating in multiple columns. You can search for data quite easily. You can see a pattern. You can comprehend the data easily. Then comes unstructured data, data that has no clearly defined structure and is not easily searchable. Data such as audio, video, images, so on and so forth. At the most basic level, this is binary data. When you take a look at the binary data, there's no structure, there's no pattern that's repeating. The only pattern that you can see is a bunch of ones and zeros are there, but that's not really a pattern, that's just technology that is being used. Other than that, there's not much that you can do to understand how the things are working and how you can make searching and scrolling effective here. Now let's take a look at the different data discovery techniques that are available. So there are several techniques which you can use to perform data discovery, such as metadata, labels, and content analysis. Data discovery using metadata is really especially useful because many of the companies use this. Now, metadata is data about data, such as data when a file was created, column name was created, when the last time these things were edited, what is the last version of the file, the who created the file, when the file was created, when the file was last modified. There's a bunch of data about a file that could be considered information useful for data discovery process. It can be used to find and extract useful information, such as if the data was essentially modified in the last few weeks, that means that it is a useful piece of information. However, if it hasn't been touched in a month, then that means that it could be moved to an archive storage. Maybe we can store it into a data warehouse where this data will be worked on and will get some insight out of it. Then comes labels. Labels are descriptions of data, such as the description of what an image contains. These descriptions can be used to group and classify data. For instance, if you have certain images that contain a particular piece of information that is useful to you, let's say that you are trying to build a system that can determine whether or not a particular image contains a traffic light, and multiple traffic lights are going to be inside an image. They can be labeled as containing the classified information or containing the traffic light image, and the other one would be considered not containing the traffic light image. You could go even further and further classify them as when they are containing the traffic light image is one of the lights in the traffic lights on, which one is it? Is it red, green, or blue, and so on and so forth. So these are all done using labels, and labels provide very useful information so that we can then discover the data based on the labels that are provided. Then comes content analysis. Content analysis allows us to analyze the documents and artifacts of various formats such as text, pictures, audio, video, etc. This analysis allows us to examine patterns and extract features from the content, such as emotions being shown in a review, etc. If you have some online review that is written and you want to analyze the content and figure out how the content is being structured, what are the words that are used, what are the keywords that are used, does the reviewer review the piece of information favorably or unfavorably? Is he or she happy with the product? Is he or she unhappy, satisfied, unsatisfied, sad, happy, angry, so on and so forth. So this is also very useful. Now comes data discovery issues. Now, data discovery is a complicated process, and as with any complicated process, there are several issues associated with the data discovery process. Let us take a look at them one by one.
Just a quick info, guys. Intellipaat provides CCSP certification training, mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
The ones that we'll be taking a look at are poor quality of data, dashboards, and hidden costs. Poor quality of data basically means that the discovery of data among data that is not correctly classified, that is not correctly cleaned, that contains incorrect information, missing information, that could be a source of a lot of problems. And this could lead to a lot of misleading statistics and misleading facts that may or may not be true because the data is so poor. So poor data can be a major cause of issues. Then comes dashboards. Now, a dashboard is an important data visualization tool in data recovery. However, it can be difficult to build based on the complexity of data and the size of the data. If you have data complexity, data shape is very complex, then visualizing it is going to be really difficult considering the edge cases that you might have to consider, in which data is nested deeply within one another. Now you have to go through each of the nested places to find out whether or not some data is available there, and if there is, then you extract that data, go back up the hierarchy, and then go down. This is going to be really difficult, so it could be an issue, especially if the data comes from a source that you do not control. They can even change the data, and the shape of the data is changed, then your application needs to adapt to that as well. Then comes hidden costs. Costs associated with data discovery are difficult to estimate. These costs estimate may turn out to be underestimated, or hidden costs may emerge if the data is not analyzed properly for the estimation process. So understanding what kind of data you have, what is the complexity of the data, and how you are going to go about doing this will allow you to figure out what are the hidden costs. Cost may not only be monetary, it could also be time-based cost. For instance, if you determine that it's going to take you 3 months to create a data discovery pipeline there, but it ends up taking you 6 months or 7 months. That means more and more time is being used and more resources of the company are being used here. So it's important to understand how you're going to do that. With that, we have understood all there is to understand about data discovery in the cloud. It is a process that is very important, and these are the issues and techniques that you can use in order to do data discovery. Now let's take a look at data classification. Data classification, or how you can implement data classification in cloud computing. What are the things that you should know before you implement data classification? Now, data classification is the process of analyzing structured or unstructured data and organizing it into categories based on file types, contents, and other metadata. There are several options in data classification, such as mapping, labeling, and dealing with sensitive data, etc. Now, mapping refers to the process of creating links between features and data in a dataset. Suppose you have some dataset that contains images of famous people. The mapping is going to be the features and the data that is considered it contains in the dataset. Or another way of thinking about it is if you have some medical data, then you can create several links between several kinds of data. For instance, one kind of a feature would be if the person is old or new, or you can say old or young. And in cases like this, you can create a link between the old feature and attach it to one particular file and one particular row of data, and then the young people will be given the feature of young. This way, it's easy to categorize and group data together. So for instance, if you have some data that contains just the age of people, but you want to classify them as being old, as being senior citizens, as being young, as being teenagers, as being babies, as being adults as well. So you can generate these features, and then you can just map them to those. Then there's labeling. Labeling is the process of assigning classification labels to determine a class in which a particular row of data belongs to. So taking forward our medical information dataset, let's say that we want to determine a particular person has diabetes or not. If it turns out that a particular person has diabetes, then the data in the row in which it is existing will be labeled as positive. Positive meaning that the person has diabetes. It's a yes or no binary classification. You could also put yes or 1 or 0 as well. A person who does not have diabetes will have 0 in their row. The meaning of 1 and 0, yes or no, and positive and negative are already predetermined because we are checking for a person having diabetes or not. Then comes sensitive information. Whenever trying to deal with data classification with sensitive data, special needs to be taken care of data that is being used for data classification, such as the protected health information, also called PHI, personally identifiable information, PII, and cardholder data. So depending on the kind of data that you're working with, there's special kinds of care you need to take care of when you're dealing with these kinds of data. So these are the considerations that you need to take care of. These are the processes that work with data classification. Now let's see how we can design and implement information rights management systems in cloud computing environment. So information rights management are technologies and processes that protect sensitive information from unauthorized access. For IRM, we have to understand these things, the objectives and the tools. So let's firstly take a look at the information right management's objectives. Now, as with any technology, there are several objectives that are associated with the information rights management system. But the main ones are data rights, provisioning, and access models. There may be other objectives that you can tack on based on how you want to structure your applications and how you want to deal with the entire data access models. But overall, you have to understand that these are the basic tenets or the objectives that we need to understand. The first one is data rights. As the name suggests, data rights give people authority over their data. They offer the right to access, change, move, and delete their data. Essentially, this is to determine what person has what right over what data. If I create some data, do I then have the right to manage the data, change the data, basically be the administrator of the data? or does the organization that I am working for has the administrative right and I only have the right of requesting certain permissions for that data. That is covered under data rights. Now, which one of it is for you is something that you need to determine based on the use case that you have. To give you an example, let's say that you want to essentially create a system that works only for yourself, that you're the only person who will be using it, and the data is only going to be the data that you create. So think of it such as a blogging system. In cases like this, it is a good idea to give the employee who will be working with the data complete access over the data. They can change the data, they can add the data, they can delete the data. Whether or not some information is being collected about how the data is changing, what are the changes being made, who are making these changes, when and why, that remains up for consideration, and you can do so yourself. But in any case, data rights essentially means that you determine the people and the authority that they have over the data. So if you're someone who has been using blogging platforms such as WordPress for a company, then and you move it to the cloud, then several of these facts apply to you as well. Then comes data provisioning. It is the process of creating and deleting users from a system. These users have authorization properties associated with them, such as roles, groups, permissions, etc. It may seem really easy to create and delete users, also called provision and deprovision users. However, there's a fair bit of complexity that is associated with it once you take into account the complex networks of attributes that are associated with each user. A user can have different roles such as administrator, viewer, commenter, so on and so forth. And a user can belong to several groups, such as the admin group, the managers group, the management group, and many other kinds of groups. And each person can have several permissions such as being able to access some data, being able to remove some data, being able to spin up some servers and delete some servers, being able to add new infrastructure resources such as servers, load balancers, networks, virtual networks, etc. In all of these, the important thing to understand is that all of these needs to be managed using a permission system. The permission system's primary job is to take care of whether or not you are able to create some data, delete some data, and are the permission applied to you removed once you have been deprovisioned. So if you create a user and you then deprovision that user, do you deprovision their entire identity, or do you deprovision the rights given to them for certain resources? So do you disallow the person from creating new servers, but you keep their identity in your identity management systems? All of these are things that you need to consider when you're designing the security and authorization policies. Which is why it is determined that these systems are very complicated, and they should not be given in hands of every person, because if people don't have the strong understanding of authentication and authorization policies that need to be set for a secure environment, then giving them that kind of access is going to be really problematic for the people who do give them that kind of access. Then comes access models. An access model defines what a user can do and cannot do on the data based on several factors such as their roles, permissions, and the groups that they belong to. So in provisioning, what we do is we create the user and we remove the user, and we take care of all the other aspects associated with them. As mentioned before, this gets particularly complicated because of all the values, all the attributes associated with the user, and depending on each use case, we have to determine a particular solution. Access models, on the other hand, determine which role can access which resources, which role can access which data, what permissions are given to a particular user, what groups are associated with particular permissions, so on. To give an example, if you have a cloud computing infrastructure and you are managing the rights and management of everyone, then if a person builds an application and they are the developers, then they should be given access to servers on which the application is being deployed, and the right access to the servers on which the data is being written, or treated right access. On the other hand, if a person is an administrator, then they should have full access over all of these. Preferably, only one person is given administrator access over all of the resources. If possible, don't give just one person or anyone that kind of access. Compartmentalizing these accesses can be a better option here as well. Another thing to notice is that there are several groups as well. So depending on what kind of permissions you're giving to a group or a person is going to be understandable. Suppose there's a person who belongs to the developer group and the management group, which is to say that they are a developer and a manager at the same time. And in cases like this, they should have access to users' information, they should have access to employees' information, their salary, and so on. And they should also have access to infrastructure resources so that the applications are being deployed and they can take a look at how they're being deployed. However, if the person then gets demoted from a manager to just an employee, then they should be kicked out of a group that gives them that access. Instead of just removing all the accesses for that entire group, we should kick out that person from that group. Again, this depends on the situation that you are faced with and so on and so forth. Now let's take a look at the appropriate tools that we would have to use to implement information right management. As we have discussed thus far, that it's not easy as it might seem to determine the rights that a person has on particular information in cloud computing environments, and how do people craft their own cloud computing information right management system depends on the tools and that are available for them. So for digital rights management, we make use of several concepts such as keys, certificates, etc. These concepts require several tools such as several tools that can perform certain tasks such as issuing certificates, revoking certificate, and certificate revocation. Different tools can do these tasks, or maybe you can create just a single tool that can do all of these tasks. It is to understand that these certificates are cryptographic certificates. It's not a piece of paper that you can just randomly create and copy and paste. They have their own cryptographic signatures, and if a particular action is authorized using a particular certificate, then that person's name is associated with it. And these keys also, these cryptographic certificates also come with keys in order to determine whether or not a person has given their consent for these certificates to be used. Specialized tools that use cryptography to issue cryptographic certificates with securely specifying users' identity and tasks that they need to be permitted to need to be created. Issuing these certificates is a cryptographic process. This is not extremely or lightning fast as multiplying to numbers maybe, or all the other tasks that we perform in a computer-based system maybe. Here we have to understand that these are specialized tools and they use cryptographic processes. This could take a lot of time depending on the strength of the cryptography that we're using. And so issuing the certificates is a task that is best left on tools, because tools are much better at issuing things and keeping track of things that are issued thus far. Then comes revoking certificates. Certification revocation is basically the process of revoking the certificate so that it cannot be used further. This is also a cryptographic process. Again, cryptographic processes may seem like a very easy term to use. However, cryptographic process are really important to understand. The important thing to understand here is that since these are cryptographic processes, that means that you do not get access to essentially do anything that you want with these things. They are properly secured, and that's why to maintain the integrity and security of the certificates and the meaning of the certificates, we keep track of these certificates using specialized tools. That's why for issuing certificates and revoking certificates, we use specialized tools. Otherwise, all we would have to do is basically just delete the certificate that is inside our database, and that would be it. But since it's a cryptographic process, there's a lot more involved in it. Cryptography uses a lot of mathematics in order to maintain the integrity of a particular system. So we need to take care of that as well.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So these are the two kinds of ways. Third one is certificate replication. Suppose a particular certificate needs to be issued to multiple people. In cases like this, or suppose a multiple simple key needs to be given to multiple people, maybe it's a public key and we have private key, we have generated multiple public keys and we need to be distributed to each person. This is also a cryptographic procedure and needs to be handled by a special tool. So these are the kinds of things that we need to take care of when we're dealing with the certification using certificates, issuing certificates, revoking certificates, and certificate replication as well. These are cryptographic certificates. They are secure. You can't just automatically create the certificate. Once the certificates are created, then the tasks that these certificates are used to authorize, these certificates are then verified by a verification system, and that certificate verification system then lets go of the task if the certificates are verified correctly. If not, then this is logged inside a a system which will be notified to the data administrator. So with that, we have understood all that is to be understood about information rights management. Now let's take a look at how we can plan, implement data retention, deletion, and archiving policies. So there needs to be policies that deal with several activities performed on data in cloud, such as retention policies, deletion policies, archiving policies, and legal hold policies. Let us try and understand them one by one. The first one is retention policy. As the name suggests, the retention policies are used in order to determine how a particular system is going to retain the data that is provided to us. So essentially, think about it this way: when you have a cloud data policy for retention of certain data, the thing to understand here is this: how the data is going to be retained, for how long it is going to be retained, is it going to be deleted after a while, and how is this going to affect the data's integrity. If someone gains access to a particular data server, is my data encrypted? Is the data that has been retained deleted immediately when I delete it? Is it a logical deletion? Is it a physical deletion? As you can see, there's a lot of policies that need to be taken care of. But retention specifically takes care of how the data is retained. What are the geographical locations where the data is copied? What is the uptime of these geographical locations? Is it encrypted? What level of encryption is there? And so on and so on. Then comes deletion policies. These specify how to securely delete the data when a specific resource is assigned to a different user. They should not be able to recover the deleted data. Let's understand this using a scenario. Suppose that you are working on a cloud computing system. You have created some data and you have been creating some data on those cloud computing platforms for a long period of time. Suddenly, the application that you used to do is no longer useful and you decide to take it off the internet. Now, for doing that, first things first, you need to delete the data that your users have submitted, such as their email, passwords, mobile number, and many other kinds of things. Now, in cases like this becomes really difficult because once you understand that you have to delete the data, you first have to realize where exactly have you put the data. Is it just in the database? Are the databases storing the data or logs inside some other files as well? Are there some cache files? Are there some servers on which locally the data is stored, so on and so forth. Using this, what we end up doing is we end up creating the policies that will delete the data. So once we end up taking our application off the offline, then we delete the data that is given to us by user by firstly deleting the databases, deleting the servers, deleting the virtual hard drives, so on and so forth. Now, it is to be done in such a way that the data that was deleted could never be recovered by anyone, whether or not they gain access to the same resource. So the virtual server that you had created to host your application stored some data. You deleted that virtual server, but that data is still being stored in some ephemeral storage. When someone creates a new server and gets assigned that kind of it gets assigned the same resources that you did, then can they still recover the data? Can they still find the data or not? These are the kind of things that we need to worry about in the deletion policies of our data retention policy. Then comes archiving policy. These specify how long the data needs to be dormant before it is archived, how long the archiving process needs to store the data for. So to give you an example, archiving is the process when you store some data that is not very frequently used. The dormant data here basically means that it hasn't been used for a long time. Suppose I create some data and I store it in a file. Then I forget about the file and I don't use it for let's say 6 months. Now that you consider some data not being used for 6 months dormant? If so, then in your policy that will be specified, and every time when 6 months pass and a particular file has not been used, then that will be moved to an archived storage. That will cause it to cost less because it's not in the raw storage format, it's in archived storage. Latency of accessing and using the file is going to be more, but since you have not accessed it for 6 months, it's a good bet that it's not going to be used for another 6 months or for a long period of time. In any case, once you archive the data, then you need to understand that how long does the archive data needs to be there. Certain organizations keep some data for archived forever, while others don't like to keep the data archived for any period of time. So in cases like this, we would recommend that what you do is you specify some archiving deletion policies in which you specify if the data has been in archive for 1 year and no one has touched the data, then it's safe to delete the data with the user's permission. Now that permission could be that they send you an email that the cloud service provider, once you log into the console, tells you that this has been the case and would you like to delete the file or review the file. And in any case, these are how these things can be done. Again, you can craft your own policies, you can negotiate with the cloud provider, you can use a cloud broker to do the negotiation bit for you. The important point here to understand is that these are the ways that you can do these things. Then comes legal hold and policies. So some data is highly sensitive in a legal context, which means that some data is extremely legally sensitive, and misuse of that data, unauthorized access of that data, all of that could lead to really high fines and criminal cases against both the person who stored the data and the place where it was stored, if the place it was stored was not in-house. So within specific regions, within specified encryption policies, there are certain regulations that we must follow when we are storing this highly sensitive data. It could be governmental data, it could be medical data, it could be anything. So these regulations need to be followed. For instance, if you are storing some data that is stored inside a particular facility, let's say that you are working with the US government, they have their own specified encryption strategies and how you can encrypt the data, how you would decrypt the data. There are specific procedures that you can follow in order to encrypt and decrypt the data. There are specified regions in which that data should reside, so on and so forth. So there's a lot that we have to be cognizant about when we're learning about cloud policies for legal data. The legality of the situation could be drastic in the sense that once you are working with cloud data policies, you do not know how the cloud data policies are going to be followed. So you can also set up some audits there as well. Several government organizations also perform random audits so that they can determine whether the regulations are being followed or not. So with that, we come to the end of cloud data policies. Now let's take a look at how you can design and implement auditability, traceability, and accountability of data events. Data events are notifications caused by creation, modification, or deletion of data. There are several factors associated with data events, such as event sources, analysis, non-repudiation, and chain of custody. And we'll take a look at them one by one. First thing to understand is that data events are not a new concept. Data events are basically just some metadata that we store about the modifications or changes made to some data, such as when some new data is added to a particular folder, when the data's contents are changed, when that data is deleted, or when that data has its content is replaced by some other contents. All of that is taken care of, and these data events contain information such as the person who changed the data, time it was changed on, when the data was created, when the data was destroyed. If it was destroyed, then this kind of information will be stored. What were the changes that were made, and at what time were the changes made. Using these kinds of metrics, what we can do is we can determine whether or not a particular piece of information was unauthorized, was caused by unauthorized access, was some data accidentally or maliciously deleted by someone, and if so, who was that person, and how can we retrieve the data back? What are the changes that were made by the person so that we can uncorrupt the data and change it back to its original form. All of this is an important tool to understand, and that's why we have cloud data events. Many cloud computing service providers provide these capabilities out of the box, so you don't have to worry about them right out of the gate. However, you do need to understand that these tools are very powerful, and understanding what are the security challenges associated with them can be useful. The first one is event sources. This is a term that is used in software development quite a lot. Event sourcing is this particular kind of software. Event sourcing is the process of keeping track of all the information regarding changes made to some data in a system, and event sources are the software that save or log this information. If you are a software engineer, then you definitely would have worked or either heard of a system like this. It's a very popular system called Git. Git is a version control system. For those of you who are unaware, Git is how software developers manage the versions of the software that they are working on. The new changes that are made by people can be pulled down from GitHub. They can submit their own changes and they can merge new changes to original existing files. Git also keeps track of all the changes that are made to the files, and the labels associated with it are the commits message. So if you have ever written a commit message, you need to understand that these commit messages are the description of the changes that you have made, and the changes that you have made are also kept as records in Git. So if you, for instance, determine that one of the changes that were made and were merged into the master branch are not good and you need to revert back to the original systems, in cases like this, what you can do is you can use you can revert to an original form of the data, or you can revert to the state of the data before it was changed. This is possible in event source systems. So this is why event sourcing is considered such a powerful tool. Similarly, in cloud computing, when data is stored online, the data, when it was created, when it was destroyed, when was it accessed last, by whom it was accessed, who changed its content, what were the contents changed from, what were the contents changed to, and several other information can be kept track of. Again, for example, in Google Docs, you can do this. All you have to do there is essentially you create a spreadsheet and you keep track of the changes that people made and when they made them. This makes it really easy to blame for some disastrous change made by someone based on the event source data that was kept. Now, let's take a look at analysis. Data analysis is also an important aspect of software of data events. These data events need to be properly logged, stored, and analyzed. Once they are analyzed, you can also create dashboards for visualization of the data. What is important for you to understand here is this. The dashboards that are created are not for us, they are for the non-technical people. Usually the data that is stored using event sourcing systems and data events are in text format. They are logged in databases, flat files, object stores, wherever we want to and however we want to store them. And after that, once the data is analyzed, we can determine trends, we can determine people who made the changes, how the changes were made, and we can create interactive dashboards that can take you through the entire timeline of the data that was changed. In cases like this, we recommend that you take a look at data services, and for that, you need to firstly understand the shape of the data that you have logged as the event sources. Then you need to understand how you can create a dashboard. Several services provide these kind of services for you, so you can just basically plug in some data or plug in some service to your cloud service provider, integrate them, and then they will fetch the data from the event sources securely and then create the dashboard for you. Important point to understand here is that even if the dashboards are created, you need to understand that these need to be done in a secure way. So if you are using an external system, then it could be difficult. Many cloud service providers provide their own systems to visualize some kind of data, so you can use those as well. Then comes non-repudiation. Non-repudiation is actually a desirable trait in any secure system. It means that it's a situation where a customer cannot deny authorship of some data and its event. So to give you an example, suppose I have some data and I made some changes to it. Those changes lead to a devastating effect, and now my data is corrupted. The organization that I'm a part of starts blaming cloud computing providers. They can, for instance, tell the cloud computing providers that this is your fault and you need to fix it. Now, in cases like this, what the cloud computing systems could do, can take a look at the event logs and just tell that, okay, this is what the event logs say. We can't change the event logs unless it's been made by your organization. That's the policy that we had set. And it shows that one employee of your organization has changed the data. That means that you are the people who need to take care of this. In cases like this, non-repudiation is actually used to essentially specify the order in which, or specify the authorship, which is determined by the event sources. So who made what changes led to what catastrophic failures, what changes led to what successful failure, successful events, so on and so forth. In any of these cases, first thing to understand is that non-repudiation is usually used in many cryptographically secured systems. So it's not something that is new. However, it is to be understood that even if we create any kind of cloud data event system, non-repudiation is one of the key tenets that we need to make sure that we are following. And then comes chain of custody. Now, chain of custody could be a little difficult of a topic to understand right off the bat. Chain of custody refers to the documentation that establishes a record of the control of transfer and disposition of the control of data. Basic idea is this: once you have some data and some people have some access to that data, when that person's access is revoked or is transferred to another person or another ID, that also needs to be checked. And when something catastrophic happens, then this chain of custody, which is I held the custody for the data and then somebody else did and then somebody else did, this needs to be maintained so that in cases of catastrophic failure, data breaches, data leakages, we can get a proper understanding of the timeline of how the data was used, and we can also determine the culprits who might have committed these issues. This doesn't necessarily mean that that the chain of custody is the only saving grace. You also need to maintain all the other kinds of non-repudiation analysis, event sourcing, and so on and so forth. However, chain of custody is an important aspect. Chain of custody is such an important aspect that it's not only used in cloud data events, but also in legal withholds. So if you have ever been involved in a legal case, there are also chain of custody is something that needs to be established. And in cases like this, all of these things need to be taken into consideration. So just to recap, the things that we have taken a look at thus far is the data events. What are data events? We understood what event sources are, we understand how the analysis of event sources takes place, we understand what non-repudiation is, and we understand what chain of custody is. All of these things collect data that is then audited by auditors, and we determine who was the culprit, who were the people because of whom particular data breach or a data leakage happened. So this is how you implement auditing, traceability, and all of that in your cloud computing system. Data events are an important aspect because they allow us to understand how the data was changed and who changed the data and how we can recover the data back.
CCSP basically stands for Cloud Certified Security Professional. So, guys, if you are planning to shift to the security domain, or let's say you are already working in the security domain, in that case, you should basically think about getting yourself certified in CCSP. Okay, moving forward, let me talk also about the different kind of profiles that you can apply to when you basically become a CCSP certified, right? So let's say you are already one of these profiles, or somebody who wants to become one of these guys, then you should actually go ahead and get yourself CCSP certified, because then these would be the kind of profiles that you would be able to apply to. And if you search these profiles on, let's say, Naukri or Glassdoor, you will see that most of them will require you to have a security certification. And no matter which security certification you do, CCSP is always going to be the best. Now, what is the reason for that? So, guys, there are more than 150,000 professionals who are CCSP certified right now. And if you talk about their salaries, then in the US, the average salary of a CCSP certified professional is $138,610 per annum. And similarly, in India, it's 13.5 lakhs per annum, right? So it's a pretty good salary, and it's basically the average salary. So there are people who earn more than this as well, and obviously there are people who earn less than this as well. But in majority, out of the 150,000 professionals that are CCSP certified, this is the salary that they are earning. Right now, this was basically launched in 2015. This was basically introduced, and this is basically a part of the ISC Square certification body. Okay, now in order to get certified in CCSP, you basically have to pass exams, right? And the exams are basically available in 882 locations worldwide, which is basically spread across 114 countries, right? So this basically tells you how widely this certification is accepted, all right? And one more stat to back that up: there are 170 countries in which you will find CCSP professionals. So it will not be like that you give CCSP certification and you get stuck in your own country. Even if you have to move abroad for any reason, it could be personal or business, you will find jobs relevant to the certification that you do. Okay, so this is one more reason that why you should become CCSP certified. The first reason I told you was that there are 150,000 professionals who are already CCSP certified. So you will be a part of a network of 150,000 people who can endorse each other. Second thing is the salary. The salary is pretty decent. Third thing is it is absolutely viable in most of the countries. There are a lot of places where you can give these exams, and at the same time, there are a lot of places where CCSP professionals exist. Okay, so this is why you should actually go ahead and become CCSP certified. Now let's move on and talk about what is exactly a cloud certified security professional, right? So let's go ahead and understand that. Alright guys, so basically CCSP certification certifies you that you basically know how to apply best practices to cloud security architecture, its design, its operations, and the service orchestration. Now, there are a lot of reviews out there for how beneficial the CCSP certification is, but according to Cloud Computing Intelligence, it was the number one cloud computing certification for 2017. Also, if you think about how many people are like you who want to get certification or who want to basically acknowledge their skill sets of cloud security, then according to a report of Spiceworks in 2018, skills respondents wanted to improve cloud security as a skill set in themselves, right? And this was the number one skill set that they want to improve, right? Also, according to CertMac 2018 survey, CCSP certification could be the next big thing. And it has become eventually the next big thing when it comes to security certifications. Also, it was basically developed by the ISC Square certification body, and I've already told you that. And it was done to ensure that security professional, cloud security professionals which are out there, they have the required knowledge, skills, and ability in the cloud security design, implementation, and architecture sectors. Right. So this certification, the employers can rely on that the candidate who has passed the certification is basically efficient in all the security aspects that revolve around cloud. Okay, so now that we have understood what is exactly the CCSP certification, right, let's go ahead and now talk about what are the benefits, what is in it for you that you should actually go ahead and become CCSP certified. So let's go ahead and discuss that. All right, guys. So the first thing that you will get is career advancement. Why? Because obviously once you get certified, once a organization or a certification body like ISC Square certifies that you're good with security, obviously a lot of companies will now reach you out when you make that public either on your LinkedIn or on the job portal that basically you have uploaded your resume, right? Second thing is, because you, when you will be preparing for this certification, you will be going through a lot of skill sets, right? So at the end of the day, when you will get certified, you will have a versatile skill sets to cater to different kind of cybersecurity needs in different organizations, right? So that's also a good point. Third thing is, it'll give you a solid foundation as well, because not only you will be working through a lot of basic cybersecurity aspects, but at the same time you will be catering to a lot of new cybersecurity concepts which have come into place, right? And because of that, you will have a solid foundation on the top of which you can add on your experience when you will start working in any of the company that basically you will be hired with as a security professional. Finally, you also will be a part of a community of professionals who are also CCSP certified. Now, how that helps is that because of this community, you will be able to endorse each other as people who are certified in the same domain. So let's say somebody in your community or some CCSP certified professional is working for a company called, let's say, XYZ. So that guy can refer you in his network that anybody who's looking for a security professional who's CCSP certified, I have a friend or I have a colleague who would be interested. Right, so that's how the community works, and that's how most of the CCSP professionals basically make use of the community. Also, you will get better visibility because, like I said, you will be getting certified. You can basically add that in your resume. You can also add that on your LinkedIn, and because of that, you will start appearing in a lot of search results where people look for security professionals. And finally, higher salaries. So most of the people who are in the security domain but are not certified are earning less than 35% of the salary with the same skill set when they are certified, right? So if you are a person who is planning to move to the security domain, obviously it's going to be beneficial for you. But if you are already in the security domain but are not certified, with this certification you can earn an extra 35%, or you can get a hike of 35% once you get CCSP certified. And this has been basically this number we have got from a research or a survey which ISC Square itself conducted. Okay, so guys, these are the benefits which basically can help you when you get CCSP certified. Now, apart from that, ISC Square membership, you will also get a ISC Square membership, which also has a lot of perks, right? For example, you will get a lot of online ISC Square professional development courses, right? You will get free subscription to their security magazines. You will get, discounted prices for IC Square events, and this discounted prices is only basically valid for IC Square members. You will also get frequent expert-led webinars, which will basically talk about the latest security issues and how to tackle them, right? You will also be able to start your own IC Square chapter. Let's say if you want to do that, you will also have a lot of volunteer opportunities. Let's say you can basically go ahead and share your expertise with a lot of companies which probably cannot afford you, right? And also you will have digital badges which will be issued to you by IC Square, which you can add in your social media, you can add in your social or your professional network, anywhere you can add it, and that will basically give you again a boost of visibility of that you are CCSP certified. Okay, so guys, these are the benefits of being CCSP certified. Now let's move on and talk about how you can become one. So now let's talk about how you can basically crack the CCSP exam. Alright guys, so now let's go ahead and understand the exam overview. So guys, there are basically 6 domains in the CCSP exam which you will have to master, and all of them have basically been divided or have been given a certain percentage which will constitute towards all the questions which are basically asked in the exam. So you can see that all the domains such as cloud concepts and architecture, cloud platform and infrastructure security, cloud application security, cloud security operations, they're all at 17% distribution in the exam questions, and the 19% of the questions will be on cloud data security, and finally 13% of questions will revolve around legal risk and compliance. Now when you talk about the exam, in total it will have 125 MCQs for you to attempt. You will have 3 hours to attempt these MCQs, and the score that you have to get is 700 out of 1000 in order to pass this certification. Okay, this exam will be available in English, and you can give it at Person View data centers, and this will cost you around $599 if you wish to proceed and give the exam. Okay, now this basically requires a minimum of 5 years of experience in the IT industry. If you want to give this exam, this is the requirement, and apart from that you should have 3 years of experience in the security domain as well. Apart from this, you should have 1 year of experience in any of the domains that we discussed that will be asked in the exam. And in case you do not have that experience, what you can do is you can basically, get a certificate for CCSK, which is basically Cloud Security Knowledge. And this can basically, replace that 1 year of experience that you require in one of the domains which will be basically asked in the exam. Apart from that, if you are, let's say, a CISSP certification holder, which is basically for cybersecurity, right? If you are certified in that, then you automatically meet all the requirements that are required for the CCSP exam, which is also a plus. So if you're one of those who have the CISSP certification, then you don't have to worry about the number of years of experience that you have. All right. Apart from that, once you basically get certified, I've already told you, you can get endorsed by your peers, by the other people who are certified in CCSP on professional networks such as LinkedIn, etc., or even the ISC Square membership circle. You can get endorsed over there so that people can refer you in different companies where other CCSP professionals are already working. And apart from that, you will have to recertify yourself after every 3 years to get to be updated with the market. And the way you can get yourself recertified, or the way you can make it easy for yourself, is by earning CPEs. What are CPEs? CPEs are basically continuing professional education points, right? You earn these CPEs when you basically attend various mediums through which the new cybersecurity threats are taught about, and how to basically tackle them is also taught, right? So these CPEs can be earned by attending trainings and events, by volunteering in IC Square certification exams. You can also, read the magazine that you will get, of course, free of cost once you get certified, and also joining webinars and e-symposiums, right? So these will help you to gain the required skills, the required knowledge, which will be an additional to whatever knowledge you already have, and this will basically help you to crack the certification, which again you will have to give after every 3 years in order to be a CCSP professional. Okay.
Just a quick info, guys. Intellipaat provides CCSP certification training mentored by industry experts, the course link of which is given in the description below.